AI major at Plaksha University. After completing his PhD at NTU, Singapore, Dr. Sharma previously served as the associate professor and the lead of the computational social science group at the University of Tartu in Estonia. His research focuses on problems related to understanding societal issues, such as misinformation, mental health, and user behavior using digital traces, such as financial transactions, call records, and social media. Professor.
Thanks, Ananya. Welcome, everyone, to ConfAI. It's the first day. So, what's ConfAI? So, ConfAI vision is to bring AI practitioners from academia, industry, policymakers, and I'll give you a glimpse of them in the next slide, to bring them here in ConfAI. And the idea is that when they come together, they create an ecosystem, and this confluence of all these eminent people, researchers, the idea is to bring together and create solutions which are really for the society, and they work in real time. So that's the whole idea of ConfAI. And as I promised, I'll give you not only theoretically, but practically who these eminent speakers are. They are coming from academia, from industry, and also from government, who are very much into policy making of how and where to move AI in right direction. I'm also thankful to distinguished our advisory committee members, Professor Bala, Professor Uday Desai, and Professor Sandeep Juneja, who helped us and supported us in bringing everything together. And as you know, ConfAI, we are organizing at Plaksha University. And I would really like to welcome Professor Rudra Pratap, who is a founding Vice Chancellor of Plaksha University, whom we fondly call RP. And prior to joining Plaksha, he served as the Deputy Director of ISC Bangalore, a pioneer in the field of micro and nano electromechanical system. He was also the founding chairperson and professor at the Center for Nanoscience and Engineering, SENSE in short, at ISC Bangalore. Thanks, RP.
Good morning and a very warm welcome to our campus. We are delighted and grateful that you could take out time and come from far off places, as far as Bangalore, to attend and enlighten us in this conference. The idea, as my colleague Professor Rajesh Sharma said, the idea of ConfAI is to bring different sectors of society and deliberate on AI, what we can do. Of course, you know, there is so much of discussion about AI all over the world. However, it's very easy to get lost in the noise. What we want to do is look at the real signal in AI and see how India can leverage AI for itself, for its growth, and for its journey. As a country, we are from what you generally read in newspapers about AI. Yes, for efficiency, we must use AI, that everybody knows. For productivity, we must use AI, but not at the cost of human beings. That's our imperative, and we must keep that in mind. So, since you are here at Plaksha University, many of you are here, coming here for the first time, I thought I'll take this opportunity to tell you a little bit about Plaksha itself, you know, where you are. Since we are a new university, you may not know what this university is all about. So I'll just take you through a couple of slides to tell you about Plaksha itself. You know, the name itself is very, very interesting. It's the name of a tree from which river Saraswati is supposed to have originated. in the foothills of Sivalik. That's where we are. On a clear day, you can see Sivalik from here. So the name embodies a place from where knowledge flows. That's the idea. There are three pillars of Plaksha, particularly, reimagining tech education, which was something that attracted me to Plaksha. 21st century education got to be very different from what it was for last centuries. We always look forward, we don't look back. And therefore, whatever we do has elements of or is architected on what the future will look like. Fostering tech innovation and entrepreneurship is one of our pillars. We are backed by 150 entrepreneurs of modern India who are, most of them tech entrepreneurs who made successful companies, and that becomes our DNA. And addressing grand challenges through interdisciplinary research, this is reimagining how research is done in universities. Just a snapshot of where we are in our journey. We have 650 plus students on our campus. That includes about 30 PhD students, the rest of them undergraduate students. This is our 5th year of operation. So we have 4 years of undergraduate batches. This year we took 232 students. Our first batch was 83 students, 81 students graduated and were placed really successfully. They have very good careers right now. That gave us a big high that industry endorses the kind of changes we are doing here. We have 50 plus full-time faculty members, various research labs. Please take opportunity, please take time off, whenever you can, and visit our research labs. You will see what we are doing. There is continuous fundraise because it's a collective philanthropy university. This is our journey, starting from 2015-16 as a brainstorming to 21 when we opened our campus to today. We are sitting in this conference. It's organized by Harish and Bina School of AI and Computer Science. We have a new school that we launched early this year. And there is also a Bini Bansal Institute for Inventing the Future, which works on AI plus X. The School of AI is anchored in partnership with UPenn, and Bini Bansal Institute for Inventing the Future is anchored with UC Berkeley. You can see these two institutions, and they're going to be housed. It is still under construction. Actually, the building exists next door, Axis Bank Future Tech Building. Put together these 3 initiatives, we raised roughly about 300 crores to support all initiatives in AI at this institute. Our school has very, very good faculty members. We are very proud of them, very fortunate that we could get them from all over the place, well-trained, and more importantly, more than their training, their forward thinking is what attracts me to them, and that's why they're here. Now, talking about the conference itself, we started this conference in 22, just so that you know, we are not riding on the AI wave. We started our major in AI and CS in 21, which was designed in 2019 and 20. As academics, we all knew what AI is going to do. So it predates any ChatGPT era revolution. So we had our first conference on AI in 22. That was by invitation only, which is what we like to do at this university. First brainstorm with some leaders, think about what the path should be. In 23, we opened it up for also some submissions. We had 60 plus paper submissions, and the areas that we started focusing on, we expanded those areas. Now, this year, this is being organized by the Harish and Bina School of AI and Computer Science. Now, it's different from what it has been, so I'm going to call back my colleague, Professor Rajesh Sharma, to take us through from here.
Yeah, thanks, RP. So just to add what RP said, there is a campus tour being arranged, so please ask at the reception for more information. So moving forward and talking more about ConfAI, especially from this year, what we did, we called for abstract, we changed our direction a bit, and pleasantly, and I'm very happy to share that, we received more than 400 submissions, and the themes, which are there on the slide, but not exhaustively limited to these topics, but majorly we had focused on language and translation, medical imaging, computer vision, social computing, and cognitive modeling and optimization strategies. So what we did, we put the abstract which we received and been selected into, to create a word cloud of that. And to surprise, AI told that AI is at the center. So, and then the other topics which emerged, like reinforcement, efficiency, that the model should be language, which, as you know, in India, they're all multilingual, right? So India needs this direction in which we need to take care of the languages which are spoken in every corner of the world, or specifically in India, right? Medical is another area where we need healthcare attention, right? So this is how we have organized the themes in different 3 days. The day one, it's mainly focused on language models and translation, and then taking care of the healthcare and medical, and also the robustness in computer vision. Day two, which is mainly about invited speakers, and there will be a very interesting panel discussion, which is about core challenges in AI research. Okay. And on day three, we have again presentations about multimodal and social computing, a topic very near to my heart, and also taking care of explorations in AI about environmental intelligence and optimization strategies, very important topic. So let me briefly talk about how the review process was done. As I mentioned, 400 plus submissions we received. 18 experts, reviewers were there to help us, thankful to them. And each abstract was reviewed by at least 2 reviewers. And then we selected top 20 submissions out of them. So the acceptance rate is 5%. Now, not to undermine other top AI conferences, but our acceptance rate is much lower than other top conferences. Okay. We also took care of DEI, diversity, equity, and inclusion. 1/3 of the presentations are by women speakers, and 2/3 are there. The presentations will be coming from Tier 2 or Tier 3 cities. And this whole represent 10 plus states of India. And we are also have 15 poster presentations. So please look out for them during lunchtime and other high tea sessions. And thankful to Plaksha, PhD, and undergraduates who have also contributed to this 50. That connections are going to happen in a very nice environment in Plaksha. Okay, so just to give you attendee profile, so ConfAI, we are at a very early stage, but we are very proud that we are able to attract and get this visibility that attendees are coming from Ashoka universities and other top institutes like DRDO, IIT Madras, Roper, and JNU, and also from industry as well, like Rocket Learning and Vehant Technologies. Okay, now I would like to invite Dr. Siddharth, who is a general co-chair for ConfAI with me. Dr. Siddharth is an assistant professor and lead of the Human Tech Interaction Lab at Plaksha University. He completed his PhD from UC San Diego and was senior human factors researcher at Microsoft US before he joined Plaksha. Currently, his research is in investigating and modeling human physiological responses to improve cognitive well-being and enhance human-AI interaction to boost productivity, safety, and creativity. Welcome, Siddharth.
Thank you, Professor Rajesh. So as we begin ConfAI 2025, I would like to share and talk about just one idea, which is conversations that shape AI futures. This you will see everywhere next to ConfAI this year. So as you can see, I have written futures there. That is deliberate. We don't believe that there will be just one future of AI. In fact, in this multiverse of possibilities that we inhabit, we don't know what the future of AI will look like, and those are the kind of conversations we would like to have in this conference. In terms of the kind of futures there could be a future with AI that is akin to Aladdin's lamp that will solve all of humanity's problems like a genie. It could also be a future, unfortunately, as many people are postulating, in which a Frankenstein kind of monster may be unleashed and it may be not beneficial for humanity. In fact, it may lead to the destruction of humanity. And there is a third school which is saying all of this is a bubble. It is like Sheikh Chilli's dream and the whole bubble will just burst out. We don't know which future will unfold, but those are the kind of conversations we would like to have. And we have wonderful eminent speakers to spark these conversations. So I'll just go through the kinds of conversations we are going to have with them. To build these conversations, the remarkable set of speakers that we have, that also my colleague Professor Rajesh just introduced. The first set of conversations will revolve around how AI learns, how it adapts, improves, and acquires expertise. Behind every breakthrough system lies a story of learning from data, from feedback from the world, and increasingly from humans. Our speakers in this track push the boundaries of what machines can understand, how they come to know it, and their work reminds us that AI is not magic. It is built, trained, refined, and challenged. And in exploring these frontiers, we also reflect on how we learn, how we adapt, and how human expertise and machine intelligence can evolve together. The second stream of conversations will take us into the heart of practice, AI in autonomy and nation building. These conversations ask a different kind of question, not just what AI can do, but what AI should do for a country, for communities, and for public systems. This is where technology meets governance, scale, and the messy, beautiful complexity of society. The speakers leading these discussions bring experience from crafting policy, deploying AI at national levels, and building systems that matter to millions. Through their insights, we explore how AI can help shape a more equitable, efficient, and resilient India. Our final set of conversations will focus on trustworthy AI, on safety, responsibility, and control. As AI systems become more capable, the question is no longer only about their power, but also the guardrails that keep that power aligned with human values. What does it mean for an AI system to be dependable? How do we design for safety without stifling innovation? And who takes responsibility when intelligent systems act in the world? The speakers in this track work at the cutting edge of robustness, oversight, fairness, and accountability. Their conversations help us navigate the delicate balance between unleashing AI's potential and ensuring it remains firmly in the service of humanity. These, to me, are the conversations that shape AI futures. Plural, evolving, and uncertain, but rich with possibilities. And we hope that through these dialogues, all of us here will learn something that help us build a wonderful world together. So with that context, I announce ConfAI 2025 to be open. Now let me introduce you to our first opening keynote speaker, Dr. Venkat Padmanabhan. Dr. Venkat Padmanabhan is the Managing Director of Microsoft Research India, where he has spent nearly 2 decades shaping the lab's scientific direction and advancing foundational work in mobile and network systems, particularly in sensing, wireless communication, and intelligent data-driven infrastructure. After joining the India lab in 2007, he founded and led the Mobility Networks and Systems Group, later serving as Deputy Managing Director. Prior to that, he spent over 8 years at Microsoft Research Redmond, following his PhD in computer science from UC Berkeley and BTech from IIT Delhi. His work has not only shaped academic thinking, but has also directly influenced Microsoft's products and technology licensing efforts. A highly distinguished researcher, he is a fellow of INAE, IEEE, and ACM, and a recipient of the Shanti Swarup Bhatnagar Prize, reflecting both his scientific excellence and enduring influence on the global computing community. What sets Dr. Padmanabhan apart is not just the breadth of his accomplishments, but a rare research philosophy, an ability to see around corners, to sense shifts in technology, persist through uncertainty, and imagine futures that don't yet exist. His work consistently asks a simple but profound question: how can research not just advance knowledge, but reshape the real world in meaningful, lasting ways? Dr. Padmanabhan, please.
It's a real pleasure and honor to be here. So I want to thank RP, Professor Bala, and everyone else for inviting me. In fact, I think the invitation is the only way I could have gotten here. With 5% acceptance rate, I would not have made it otherwise. So thank you for the invitation. Not this year, the other one. Thank you. Yeah, so and by the way, I was here for the first ConfAI, I think, in 2022, and it is amazing to see the growth in the university, so I really want to congratulate everyone here for what you have accomplished, and I'm sure there's much more to come. So this is the title of my talk, Perspectives on Having Impact Through Research. I mean, I've deliberately not used the word AI anywhere there, right? And I think the reason is that I think a lot of what I will talk about, I will of course touch on some AI work that my colleagues have done and I've done as well. But I want to really touch on some messages that I believe are much bigger than just AI, right? They are sort of really about how to think of research and how to think of having impact at scale through research that transcends the particular area that might be hottest right now. So one can start with basic questions of what is research and what is impact, and how you can have impact through research and so on. The thing I want to tell you is that there's no one answer to these, right? That's obvious, right? So what I will provide here is my admittedly biased perspective on what my answers are. And you should really decide for yourself what makes sense and reject the rest. Right? And I think that's important because, especially for young students, you have to keep in mind that what a speaker might tell you is not the truth. It is their perspective on what the truth might be, and you have to really decide for yourself. Right? So that's sort of important. So with that as a caveat out of the way, the way I see, research is really about creating new knowledge and or finding ways of applying knowledge in new ways, right? And so that leads to this classic dichotomy between so-called basic or fundamental research and applied research. In my view, that's a false dichotomy, right? Because in fact, there is this nice book called The Pasture's Quadrant, which tries to lay out research on these two axes, basic versus applied, and the quest for quest for application and so on. And so if you look at the quadrants here, there is Edison. Does this work? Okay. There's Edison in the bottom right, where he was doing pure application of known knowledge. There's Niels Bohr on the top left, where he was trying to further knowledge without really caring about application. But then in the top right is Pasteur, who actually, if you read his history, was trying to do some project for the winemakers in France. It is a very applied problem. They actually wanted to solve some problem. In the process, he made fundamental contributions to germ theory, and of course pasteurization was something that came out, right? So in some sense, the quest for solving a real problem led to fundamental breakthroughs. And I really believe that idea of sort of use-inspired research or use-inspired basic research is a very good paradigm to consider. Again, it is not universal, but this is another illustration of that. So there's this other really nice book on the history of Bell Labs. And for the younger people, I think Bell Labs is no longer what it used to be, but for the younger people, Bell Labs, for the good part of the 20th century, was one of the top places in the world for research, both fundamental research and applied research. Things like the transistor, the Unix operating system, all those things came out of Bell Labs. And so the myth of the Bell Labs, the Bell Labs myth is that they hired people and let them do whatever they wanted, and great things happened. Not quite. If you read this book, they were hired and they were told that their job is to make, AT&T was the company, right? Or Bell Telephones, I guess. Make their product, which is really communication, better. Make it possible for phone calls to go over longer distances with better quality, lower cost, and so on, right? So that is really let's call it the application they were after. In solving that, they came up with fundamental breakthroughs in communication theory. Even the transistor was invented because the vacuum tube-based amplifiers had noise issues and so on. So they had a North Star, or they had a driving application that then led to research. So anyway, this is my perspective. I think it really often helps, and I think Plaksha's philosophy is very much like that as well, right? Look at real-world problems and so on. The next question is, what is impact? So there I will just sort of play out a little clip from a speech I had to give at IIT Delhi a few years ago. Today, in this connected world, sitting here in the computer science department in Delhi, you should aspire to do work that people on the other side of the globe, maybe California or in South Africa, are talking about development. These are people who don't know about you, but they have read your paper, they have downloaded your software, they have seen a blog by you, and they're talking about it. That is something that I think each one of you can aspire to do. Yeah, so I think what I really want to say here is, when someone else far away from you, who doesn't know you, is talking about you and copying you or adapting your work, that is impact. And I think that is the ambition all of us need to have, right? Really, we have to do things that are so unique, so interesting that the world takes notice and uses your work, right? And it's not easy, of course, but if you set yourselves to do that, I think that will happen. So that's really what I mean by impact. So then impact through research is really combining the new part with something that matters, right? Because that's when someone will take notice. If you do something that no one cares about, they're not going to take notice. So just from my experience over the past 25 years, there are some recipes that I found to be useful, and in the rest of my talk, I'll illustrate each of these with some examples. The first is to anticipate technology trends, right? Look out into the future. Of course, in this AI world, it's very hard to look too far out, but ideally look out to the extent you can. And imagine, like, if the bottlenecks of today were solved and, AI became inexpensive, it could be invoked sort of, when required, it runs on the edge device, things like that. What would change, right? A good example, I think I was talking to RP this morning, is, and it's a combination of the first and second bullets, is education, right? How do you reimagine education in the light of generative AI? It's like when cars moved from stick shift to automatic, certain set of skills need not be taught to drivers, right? What's the equivalent of that for education? And I think RP already has some thoughts, so I'm sort of preaching to the choir here, but The point is that ask questions like that. If this technology progresses, what is the new future it will enable? So anyway, so that's the first two bullets. There's also research you can do which is kind of here and now, right? And again, I have an example when, like 3 years ago, GPT-4 came out, and ChatGPT came out, and things became, very apparent that this thing can do fairly magical things. Of course, it's got flaws, but it's pretty magical. Then you can see immediate application. You can see things that could be changed today, right? So that's really about seizing the moment. And for some problems, that's the right thing to do. The other thing is leverage your competitive advantages, right? So often it comes from location or the context you're in. And again, I have examples. But sitting here in Plaksha, I think you have an amazing university, but also you're very close to this top medical university, right? PGI. So maybe that combination, and I think it's not very far. So that combination is something that not many other places have, right? So leveraging, there's no point competing on where the other person is strongest, right? You have to sort of find what your strengths are and leverage that. So that's the general philosophy I have. And then finally, doing foundational work that may not be the flashy thing, right? But it really underlies success. So I will talk about this as well, like a project which is not maybe viewed as an AI project, but it really fundamentally enables AI, right? And I will talk about that, and let me keep it as a bit of a mystery for now. So in the rest of my talk, as I talk through different projects, I'll just use these little pictures to illustrate these points, right? So looking out to the future and anticipating trends, reimagining the future, seizing the moment, leveraging your location or other advantages, and then doing foundational work. Now, so those are what I would call as recipes. There are some best practices in my experience that apply to all of these, right? One is just to be persistent, but to be persistent in a smart way, which is with breaks. Like, let's say you had a great idea, you tried it, you hit a brick wall. Maybe you can revisit it some years later when the stars are more aligned. Maybe the technology has moved, and now what you thought would be a great idea is actually more feasible. The second is to expect surprises, right? You may have plans on what you're going to do, but then the actual success you have is something different, and that's fine, right? Research cannot be predicted. The third is leveraging collaboration and partnership, right? I mentioned the medical university example, but as I'll talk about in my talk, many of our successes or relative successes have been enabled because we found complementary partners who had skills that we didn't have, and it was mutually beneficial. Then turning ideas into artifacts. I think this is extremely important. I think for a while at least, the research community, even in industrial research, people started chasing papers. Okay, how many PDFs can I produce? How many things can I put out there? And nothing wrong with papers, right? All of us have written papers, and that's certainly one way of getting your message out and having impact. But especially in today's world, where a single AI conference, NeurIPS I think is next week, probably has like 3,000 or 4,000 papers. Just having a paper out there, even in a top conference, it's unlikely you'll have the impact you want because it's very hard to get noticed. So making things available as artifacts, code, models, data sets, that then catches on, right? People start using it. That is something that will really make you stand out. And finally, yes, luck plays a big role in a lot of this, but I think it's your job to create luck. And luck is a probabilistic phenomenon, so the more times you flip the coin, the higher the chance that you'll actually land on heads and win, right? So anyway, so that's sort of at a very high level. This, and then, in terms of pathways to impact, it is, science, industry, and society, and I'll touch on all of these as I go along. Okay, so with that as the prelude, I'm going to talk about 5 projects, a couple that I worked on myself and others from colleagues, that hopefully illustrate some of the points that I mentioned. As I mentioned, some of them are AI projects, some are not, but hopefully you will find all of them interesting. So let me start with this project that was actually my first project at Microsoft Research. It's on the problem of, let's call it indoor GPS, right? We all know GPS, we all use it. And remember, this was late 90s, right? I finished my PhD in 1998, so this is really my first project then. But indoors, GPS doesn't work because of a variety of reasons, including the fact that the signal is weak and so on. Now, we were not the first to realize this, right? There was a bunch of work that happened a few years prior to us. And many of them built custom hardware-based solutions. So for example, there is this well-known project called the Active Badge project at Cambridge University in the UK, which built these IR transmitters that people would wear as a little badge. And then there would be IR receivers on the ceiling. And it will just detect your location based on that and so on, right? So, it is a very interesting system, one of the earliest to do this. But, requiring someone to deploy new hardware and wear this hardware specifically for the purpose of getting location is an imposition, right? Like, just from a system design perspective, that's undesirable, right? Because now you have to deploy infrastructure. Like imagine, putting a bunch of these here, it's going to cost you money, you have to maintain it and so on, right? So when I joined Microsoft Research, well, I don't know. Yeah, can anyone recognize what this is? I mean, it's just a board, I know, but this is what's called a WaveLAN. So WaveLAN was, you can think of it as a precursor to Wi-Fi, right? It was like an early version of wireless local area network based on RF. And during my PhD, I played with a lot of these, right? We used to have, hardware like this. And so this is what became Wi-Fi. So the bet we made was, what if Wi-Fi were everywhere, right? Remember, this is like a time when there was no Wi-Fi around. In fact, if I jump ahead, we started this project in 1998, and 802.11b, which was the first popular spec for Wi-Fi, came only a year later, right? But it seemed kind of obvious, I guess, that wireless networking seems very useful. People will also have mobile devices. There were no smartphones then. So you imagine that people will have mobile devices. And so the world, or the indoor spaces in the world, are going to get blanketed with RF and connectivity, right? Simply because of wireless connectivity. Then the question was, can we leverage that same infrastructure that people are deploying for a different purpose for the purpose of location, right? So you don't have to spend any money or any effort in deploying infrastructure specifically for indoor location tracking, right? This is really leveraging existing investments, right? Not existing, anticipated investments for communication. So that's really what we did. We came with a system called Radar. Very simple ideas, really about sort of fingerprinting in the radio frequency signal space, the space, and then sort of taking a measurement. So essentially sitting here, I can see 5 access points with different signal strengths. That will then allow me to calculate roughly where I am, right? So that it's a very simple idea. So in some sense, just going to the top right, we did foresee the future, or we did, look at technology trends and realize that wireless local area networks will take off, and they will be RF based, because there was also a competing effort to build IR based infrastructure, and IR had the problem of, it required line of sight typically to work well, right? So we kind of took the bet on RF, and we imagined a future where people will have mobile devices. We didn't think of a smartphone particularly, but they will have wireless connected devices that they will walk around with. So in terms of the impact this had, it did lead to this paper that is my most cited paper, so 13,000 citations. Also academic recognition, what's called a Test of Time Award from ACM Sigmobile, where they look at papers that were published 10 or more years earlier and that have really been influential. But the most interesting bit is industry adoption. So about a decade ago, the Chinese government put out a report on patents that were being licensed by Android handset manufacturers, because a bunch of them were in China, right? And it turns out that one of our patents was being licensed to these Android handset manufacturers. And in fact, our joke was that we had a Windows Phone product from Microsoft. It was a great product, but did not take off. I think we made more money licensing our patents to Android manufacturers than from Windows Phone, right? So the Radar patent was one of them that was this. Now let me switch gears and talk about a different project. which I did talk about briefly, I think the last time I was here, so I will really touch on the meta messages here rather than talk too much here. It is a project called HAMS on related to road safety, right? So here again, I think 2007, as was mentioned, is when I came back to India. This is what a smartphone looked like then, right? And some of the older people will remember the HP iPads and so on. And the iPhone, I think, was launched the same year, right? So this is like, there was no iPhone, there was no Android. But we imagined a future where, again, these phones were not just going to be phones for communication, but actually would become packages of sensors that could measure, that could really be used as a way to connect your computing world with your physical world, right? In fact, since the HP iPad is what we were working with and it had no sensors, we had to take external sensors and attach it to this phone using Bluetooth and so on, right? It was really a very unwieldy contraption. But again, we were pretty sure that at some point in the future, all this will be the package. And so we built a system called Nericel, which was arguably the earliest smartphone-based system for monitoring traffic and road and so on. And there again, your comparative advantage, if you will. I mean, one of the biggest problems you encounter in Indian cities is traffic, right? So it was obvious to us that that's a good application domain to consider. So yeah, as I mentioned, we kind of anticipated that smartphones will become these packages of sensors. So I think, again, I would say that we did look to the future and imagine the future well. But this also turned out to be the precursor to what's called smartphone-based insurance telematics. That we did not, imagine, right? So I would shrink that thing a little bit, the top right. So we didn't imagine the future. If you didn't see the thing shrink, yeah, there you go, shrinking. Because we didn't really imagine the future in its full glory. We kind of were focused on the technology and building capability. We didn't quite imagine what it might open up, right? But others did. So, back in this is 2013, I received this email from this gentleman by the name Peter Handel, who was a professor at, maybe you can't read this, KTH in Stockholm. And he's a well-known person in signal processing. He was visiting IISc and IIT Kanpur, and he said, hey, he wanted to meet as well. He could not meet then. And then when I went to Stockholm, also I could not meet him. But he did put up this paper a couple of years later on smartphone-based vehicle telematics. And I think he listed some of the projects here, top projects, and we were the second one. The one that predates us by a year is this cartel project at MIT, which has now become this company that's doing really well. It's called Cambridge Mobile Telematics. It is really about tying this kind of sensing with insurance. So, assessing how well you're driving and then using that to drive. So that's the thing that we did not foresee, right? Insurance tie-up. By the way, on a somewhat sad note, I think Peter Handel passed away a few years ago and we never met, right? So we had a lot of email exchanges. He was in Bangalore, I was in Stockholm, but we never could meet. So that was a bit sad. That's not the only thing we missed. In 2011 or 12, Google bought this company called Waze. Waze was also about sensing traffic and so on. But the one thing that they did was they also include the humans in the sensing loop. You could, as a human user, you could sort of type messages saying, hey, there's a speed trap, like there's a police man there and so on. Essentially, you could sort of augment automatic sensing with human inputs, which I think was a very smart idea. Again, we were just looking at it purely as technology. We said, okay, we'll do everything automatically. We will not, consult the human. So they got $1 billion. Google bought them. But I guess I console myself saying we beat them to a paper. They got the $1 billion. But anyway, so we wrote a paper, which again won a couple of Test Time Awards because it was viewed as a pioneering system in enabling smartphone-based telematics. There was even the cartel system at MIT was not based on smartphones. They built some special purpose hardware. So this is, but still not very satisfying, right? We built this thing, we got the paper was recognized, but we didn't actually get this out in the real world, right? So that was not very satisfying. So as I said, sometimes it makes sense to revisit problems, when the context has changed. And so almost a decade later, I decided to revisit this problem. Now, a lot of the systems, Nerisal, which we built, as well as Cartel and other things, leverage GPS data and inertial sensor data, right? So you could get a lot of information from that. But the question is, what is missing? And that's the question we asked ourselves. And we believed then, and I still believe, what is missing from these things is the human context, the driver context and the sort of driving context. And this is important because if you look at, for example, road safety and some of the top factors that affect things, look at something like speed. You might say, okay, speed is an easy one. My GPS will get me the speed, right? What's the big deal? But let me just play this little video. This is from. Yeah, so this is a 3 a.m. drive on the only high-speed road we have in Bangalore, which is the road to the airport. And the guy was going at maybe 90 kilometers an hour. His system, this is like Meru Cap, so this is way back, was I think programmed to alert the moment he went more than 80 or something, right? And he was complaining to me saying, look, this is an empty road. Everyone else is going at 90 or 100. I'm going at 90 or 100. What's the big deal? The point is that even speed, even from a safety viewpoint, is not an absolute number. It is relative speed. How are you doing relative to other people? This posted speed limit might be 80. If everyone else is going at 100, you'd better go at 100, because if you're going at 80, it will be less safe actually, right? Your GPS alone cannot get you relative speed. You need to know the external context, right? Another example, which I think a lot of these insurance applications now do, is things like sharp braking and so on, right? And so, distraction is of course bad, but let's say someone brakes sharply. You need more context to know whether they did that because they were distracted and suddenly noticed something, like this driver maybe, or someone jumped in front of their vehicle and they had to brake sharply, otherwise they would have caused an accident, right? So in which case the driver cannot be blamed. You need context, right? So that was the genesis of the HAMS project, which we started in 2016. And the way we got context is by using, the smartphones had progress, right? 2007, I showed you the iPad. By 2017, 10 years later, they were much more capable. They, quantum leap in terms of capability and sensing, and also in terms of deep learning, right? This is not the generative AI of today, but deep learning had taken off, vision models and so on were available. Also, that's the system we built. So rather than me explaining it, let someone else explain it.
One of the things that we were very thrilled to see is much of research working locally on driver safety. After all, driver safety and road safety in India is going to be a massive issue. By taking essentially a camera, taking the front-facing camera, or the back-facing camera, the accelerometer, so think of it as multiple sensors that are there in any smartphone, and turning it into road safety. So it's sort of, first of all, it can even give you a driver's test, so it can monitor you, but more importantly, it can give you the nudges so that you're driving safely.
Okay, so that's our CEO, in case you didn't recognize him, Plaksha CEO. So now there are many possible applications that we could have considered. In fact, we started with some ideas. And then, because we were persistent, we were talking to a lot of people, we got connected with Maruti Suzuki, and through them, we went and talked to the Ministry of Road Transport. This very interesting application arose, which is driver testing, right? I think I'll not ask for a show of hands here, but if you just ask yourself, like, how many people got a license without taking a test? I think the number is shockingly high, right? And one estimate was 60%. I did take the test, by the way. I took it, I failed it way back, and I took it again. So I did it the right way. But a lot of people get the license test without getting tested, right? And so get their license without getting tested. So it is not surprising that bad things happen. So the application that's kind of taken off is applying HAMS for automating the driver license test, right? We started in Dehradun in 2019, and since then it is now in 38 RTOs, and more than 3 lakh automated tests have been done with our system. As I said, we partnered with Maruti Suzuki, with the government, also with a small company called Softex in Hyderabad. So those partnerships were really important because Maruti had the connection with the people on the ground and so on. Softex is in the business of building systems. We are a research lab. So that combination was really, really important, and again, got some recognition, the CM's award, and also made it to the short list of the PM's award. There's also, as part of that PM's award thing, they came up with this coffee table book on innovations of this kind from across the country, right? And one of them is the HAMS project. So let me just play this video that I think was prepared in Bihar, showing our system in operation.
तत्कालीन ड्राइवर लाइसेंस परीक्षण एक मैनुअल विधि है। यह विधि सभी आवश्यक मापदंडों का मूल्यांकन करने के लिए पर्याप्त नहीं है। मारुति सुजुकी IDTR यानी इंस्टीट्यूट ऑफ ड्राइविंग एंड ट्रैफिक रिसर्च ड्राइवर लाइसेंस परीक्षण को स्वचालित करने के लिए एक स्मार्टफोन आधारित तकनीक विकसित की है, जिसे बिहार सरकार के परिवहन विभाग के सहयोग से IDTR औरंगाबाद जिले में तैनात किया गया है। अधिक परीक्षण या प्रैक्टिकल टेस्ट। परीक्षण शुरू करने से पहले गाड़ी के विंडशील्ड पर एक स्मार्टफोन को लगाया जाता है। इस फोन के HAMS ऐप में उम्मीदवार को अपना टोकन नंबर डालना होता है, जिसमें पहचान होने के पश्चात परीक्षण शुरू होता है, जिसमें वाहन के अंदर कोई निर्देशक नहीं होता है। यहाँ मोबाइल फोन के कैमरा से वाहन के सामने एवं पिछले भाग की तस्वीर निरंतर उतारी जाती है। इस दौरान HAMS सिस्टम लगातार उम्मीदवार के चेहरे का मिलाप करता रहता है। जैसे ही चालक आगे प्रस्थान करता है, स्मार्टफोन द्वारा प्रस्तुत की गई तस्वीर विभिन्न मापदंडों का स्वतः मूल्यांकन करती है।
Okay, yeah. So, a few things, right? One is, we have the smartphone on the windshield, using the front camera to look at the driver, the back camera to look out in front simultaneously. One advantage of that is, compared to competing systems which had these pole-top cameras and so on, A, they were expensive. B, those kind of cameras could not see who was in the vehicle. Whether the person who's being tested is the same as the one you're giving the license to, right? That's another thing you have to worry about, right? The friend could be taking the test. So, we could do that at a fraction of the cost. The fact that we did not require an inspector in the vehicle turned out to be a boon right after the pandemic, because no driver and inspector wanted to sit in the same vehicle together, right? Again, unexpected benefit. And what's most interesting is user feedback, right? As we learned, people are fine with a computer or an AI system failing them, right? In fact, they feel good about it. Okay, I failed. But if a human had failed them, they will ascribe it to bias, and they'll say, oh, that person didn't like my face or how I spoke and so on, right? So the feedback we got was, even for this person, it was not successful, but then they saw positives. Now over time, people around the world found out about system, and we routinely get inquiries from various corners of the world about leveraging HAMS and so on, right? Which is nice. But perhaps the most interesting one is this email I got one day in 2023, like several years after we had rolled this out, from the gentleman Michael Kramer from University of Chicago, and he mentioned he learned about it from Punjab government, which is right here, right? We are here, and we had not spoken to them. So they had learned about our system by, I think, the IAS officers network, right? We did it in other states, and they talked to each other. They found out about it, and they wanted to study the impact of HAMS on actual road safety, right? So, like, okay, the fact that you have tested these drivers using a system, what does that translate to in terms of actual road safety, right? And it's an interesting question. We had thought about it. We just thought it very hard, right? We didn't take a crack. I didn't know who Michael Kramer was, so I looked him up. He's actually a Nobel laureate in economics. He got the prize the same time as Abhijit Banerjee, and so the same year. And he got it for applying randomized control trial techniques to societal interventions of various kinds, right? So the right person to sort of engage with on this question, and we started a collaboration. We had not really met until earlier this year, and finally on a visit to the US, I did meet him. And that's when I learned that he towers over me in more ways than just as an intellectual, right? You can have Teams and Zoom calls with people. You know everything about them except how tall they are. So, given the interest he expressed, I reached out to Ola, because Ola founder Bhavish is a student of mine. He was a research fellow in our lab. And as I say, he and I used to write papers together. I'm still writing papers. He has moved on to higher pursuits. So we reached out to them with the idea that we have the HAMS testing software. Many of the drivers tested with our system go and drive for Ola. So by working with Ola, we can see how those drivers performed in the months and years that followed. And the professor at Chicago obviously has the techniques, and he has done this kind of work. And so that's led to this 3-week collaboration. And it's still ongoing, but we have quantified, for example, the benefit, right? Now, accidents thankfully are not very frequent, right? Even with Ola drivers, you don't actually have accidents, but you look at the user rating on whether the drive felt unsafe, and try to see whether for drivers who I have 5 minutes? I thought I had till 10:50, right? It says 5 minutes left. How much time do I have? Oh, okay, sorry. Okay, fine. I'll keep it quick then. So anyway, so there is some sort of benefit here. Let me go a bit more quickly. So switching gears, multilingual AI. This is not my work, but my colleagues have been working on this for several years, where, as we know, AI is trained on language that's out in the web, and there's a lot of skew in that. And so there are a lot of major languages, including a lot of Indian languages, that are not adequately represented in these models. And therefore, there is a performance gap. And simply translating to English and then sort of redirecting everything in English doesn't quite work. So one of the ideas is, and there are many ideas here, but one of the ideas is, can we synthetically generate culturally relevant or culturally grounded multilingual data, right? And so that's an ongoing effort called Updesh that my colleague Sunana Sitaram has been driving. And she has released some data sets, and I think there'll be an announcement made at the AI Impact Summit in February as well on some of this, right? So if you're interested in this space, you can reach out. And so this is an example of leveraging your context, right? You're sitting here in India, immersed in this milieu of languages, and also recognizing that, and they started this work several years ago, recognizing that AI will come in a big way, and this language gap is going to be a big barrier, right? So, so anyway, let me sort of, now as part of that work, they generate synthetic data, they use LLMs to do quality assessment, but they also use people. And so we built this platform called Karya in the lab, which was then spun out as a separate company and ended up on the cover of Time magazine a couple of years ago, where the idea is to turn these language tasks into work that people can do on their basic phone and earn some money, right? So it's really a way of sort of giving people some income, at the same time generating data sets that's useful for AI. It is also, this pie chart shows the distribution of language data that went into training GPT-3. Of course, for more recent models, one doesn't know. And you see the bias here, right? And it's the English and a bunch of other European languages. So beyond just the technology, it's sort of important to have the right policy frameworks that are culturally relevant, right? And you mentioned, like, I think with RP, that what works in the West may not work here. That's absolutely true, right? So I'll give you a very simple example, right? If you're a school teacher and you're producing lessons, and in my next example, or maybe I'll talk about it there. Yeah, Shiksha, right? So let me just get to this and explain it here, right? This is an example of a project that I would put in the seize the moment category. When ChatGPT happened, a lot of people started looking at a lot of applications. My colleagues started looking at education, but not from the student's end. Nothing wrong with that, but we said, let's look at it from the teacher side for a couple of reasons. The idea is to help the teachers create lesson plans that were grounded in the curriculum and were culturally relevant, right? So for example, let's say the teacher is teaching a class on nutrition, and they want to illustrate proteins. If you use an LLM, it might sort of maybe come up with a hot dog or something which the students cannot relate to. You have to make the thing relevant to the context you're in, right? So they solve problems like that. The reason to focus on the teachers is that you have a human in the loop, which is the teacher. The teacher is obviously more experienced than the students. And so to the extent the AI hallucinates or has other issues, there is a human that can intervene and make corrections, right? The other thing is you get amplification. If you enable one teacher with AI, you can benefit 100 students, right? So anyway, so the experience has been quite positive. There's been significant reduction in the time taken to create lesson plans, and most of the AI suggestions are found to be very useful. So this has been rolled out. This headline is a bit old. It says 1,000 teachers, but since then it's gone to 8,000 teachers in Karnataka and 1,000 in Telangana. teaching in grades 5 to 10. And the hope is, with this next effort, to take it even beyond. So let me play a very quick video clip.
Shiksha Foundation started as an NGO that's focused on the education sector. We are working in 6 states across India in about 50,000 schools, impacting nearly 3 million students.
The public school system in India has been severely stressed. We found that typically a teacher handles multi-grade, multi-subjects, especially in the rural areas of the country. The biggest challenge was creating lesson plans.
Preparing the lesson plans, it was taking a lot of time because everything was manual. We were writing and writing and writing.
And that's where I felt technology can help.
Shiksha Copilot is a generative AI solution where we want to empower teachers to create engaging content for their classroom. These teachers are able to generate lesson plans, they're taking the activities that are generated, and they're using all of this content in the classroom.
Within 5 minutes or 2 to 3 minutes, I'm preparing the lesson plans.
It's very essential that any solution we roll out supports the local language.
ಟೀಚರ್ ಏನು ಫ್ರೀಡಮ್ ಇರಲಿಲ್ಲ, ಅದು ಹೇಗಿತ್ತು ನಾವು ಹಾಗೆ ಉಪಯೋಗಿಸಬೇಕಾಯಿತು. ಆದರೆ ಈಗಿನ ಲೆಸನ್ ಪ್ಲಾನ್ ನಮ್ಮ ನೀಡಿಗೆ ತಕ್ಕಂತೆ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಟೀಚರ್ಗೆ ಫ್ರೀಡಮ್ ಇದೆ.
Shiksha Copilot is based on Azure OpenAI. It's grounded in local context.
ಈ ಮಾಮೂಲಿ ನಾವು ಕ್ಲಾಸಲ್ಲಿ ಪ್ರಯೋಗ ಮಾಡೋದಕ್ಕೂ ಶಿಕ್ಷಾ ಕೋಪೈಲಟ್ ಲೆಸನ್ ಪ್ಲಾನ್ ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆದಂತ ಹೊಸ ಪ್ರಯೋಗಗಳನ್ನ ಮಾಡಿದಾಗ ಅವ್ರು ತುಂಬಾ ಒಂದು ಖುಷಿ ಪಡ್ತಾರೆ.
The problems that are faced are pretty much universal. So if we have a solution that works in just one state in India, we think that solution can go global.
Yeah, so speaking of taking this global, we took some of the underlying technology pieces. Like one is to understand multimodal content, ingest large videos and efficiently process them. And again, in the interest of time, I'll skip these. And took that along with a company called Digital Green, which is also a project from Microsoft Research India. Like Karya, it was spun out as a separate company that's in the agri-information space. And rolled it out to farmers in Kenya, where a farmer in Kenya can ask a question in Swahili, and it will go into Digital Green's large corpus of videos that may be in other languages as well, and then respond to them with a meaningful answer, right? So this is an example where, we saw the power of generative AI in being able to solve a problem here and now. And again, speaking of Plaksha, because Punjab is a big agricultural state, that's the kind of thing that you could look at as leveraging your competitive advantages. Now, based on all these experiences, like doing Shiksha and other projects, we launched just about 6 months ago this initiative with IIIT in Bangalore, where Microsoft India, IIIT, and domain partners have launched something called A4I, AI Innovation and Inclusion Initiative, where the idea is to take domains, initially education, healthcare, and accessibility, take some of the technology that's coming from Microsoft and scale it up. Even if it doesn't become a Microsoft product, it will sort of live in open source, it will live as a DPG, right? So that's something that's happening. Finally, my last bit, I talked about doing foundational work. So this is a project called Disk ANN, which you might not think of it as an AI project, but the fact is that underlying all of AI is embeddings. Every object, query, document, image gets turned into one or more large vectors, and you need to search this vector space, right, and find nearest neighbors. And so that's what Discan did. It was launched in 2018. So like RP, you said, we launched it well before the hype in AI, because my colleagues, this is not my work, my colleagues saw that this would be a need. They built a system called Discan, which is the state of the art in terms of accuracy, cost, and so on, right? And it's had huge impact, not just at Microsoft, pretty much every Microsoft product uses it. It's also been open sourced, and major vendors, startups and so on, leverage Discan, right? So this is an example of doing something foundational that is a building block. And there's a bunch of open problems around doing vector search with diversity, filtering, and so on. So I'll skip that. I guess I'll just say one other thing, which is when you talk about AI, don't just think of the application and sort of the flashy thing. Also think of these foundational things, and Disk ANN is an example of that. Okay, so that's my last slide. I will not repeat. I will conclude with that. Thank you. I hope I've left a few minutes for questions.
Thank you so much, Dr. Padmanabhan. Now we would like to open the floor for questions. We have volunteers who will hand the mic as one can raise their hands.
Hi, thank you for wonderful talk. For LLMs, the entire training data set is obviously text that has been gathered in the internet and so forth and so on. But if you look at human beings, we speak far more than we write. Take any individual, right? So the spoken word seems to be much more overwhelming than written word. Are there LLMs now that are working on audio signals, taking audio signals and training on that, particularly for Indian context? We all know that everybody says there is so little presence of written text in Indian languages that these models are biased. But there is no dearth of audio signals, the phones. Is there any concerted effort in this direction?
Yeah, so I think that's a great question. Definitely the latest models deal with speech natively, right? So I think initially the effort was to take the speech, turn it into text, and then work in the text domain. But now they can deal with speech natively, and they are actually quite capable. It is much more expensive to process speech than it is to process text. So if you look at the cost is more. So it is already happening now. The thing is that yes, people talk a lot more, but do we actually the beauty of the web is that people can just build a crawler, crawl the web, and collect a bunch of data, right? The equivalent of that for the speech you and I are having right now, I mean, maybe this is going to get recorded and it'll be online, so maybe it'll be there. But there's a lot of speech that happens without leaving any trace. Whereas a lot of written communication in the digital world leaves a trace, right? It is on web pages and documents. So I think that's the difference. But to answer your question, it's already happening, right? The latest models now are trained on speech natively. They do an amazing job, yeah.
Hi, Dr. Venkat. Right, so my question is more towards the teams that are required to make some of these things happen. We started with doing impactful research, and we often think of sort of building depth as researchers by working in similar areas for a longer time. But what do you think of building depth versus creating enough breadth to take out some of these research ventures, and what kind of teams need to be formed to do that?
Yeah, again, it's a good question. I think depth is important because I think you have to be an expert in what you do. Only then you'll be recognized as such. And then even to build teams, as I said, in many cases, it's not like we hired people to do these things. We found partners. And the reason those partners wanted to work with us is they saw some expertise in us and we saw some expertise in them. So if you build depth in something and someone else has got depth in something that is complementary, then you might make natural partners, right? So I think it's important to have depth, but be aware of your surroundings, right? I already gave examples of how a place like this in its location could leverage some of the local strengths, right? So if you're doing geospatial imaging, you go and talk to the people who are doing medical imaging work at the hospital, and then you might find some connections, and maybe your techniques can be applied in their context also, for example, right? So so I think you do need depth, but don't obviously work with blinders on where you're not aware of possible connections, right? For example.
Hi Venkat. This is a little aside from your talk per se, but general question. Because, we in academia only see so much from outside, and I guess now I assume that it's the research labs which have a much more inside knowledge on how these large language models are progressing. So all the hype that we hear about super intelligence, about LLMs and I guess artificial intelligence replacing human beings, what are you seeing, how far are we from anything like that? Or?
mean, if you're asking what AGI and so on, I mean, I'm no expert to comment on that, but I think, I mean, humans are not going to disappear anytime soon, right? I think the final solutions will be humans working in combination with AI. As I'm sure you have seen, right? These models are amazing in what they can do, right? They can solve math Olympiad problems, but they can also fail in simple tasks, right? Like 9.11 is larger than what 9.8 or something because, so I think, and there are people like Jan LeCun who are of the view that this will not get us to intelligence, AGI, right? Because it is true that, you know, humans, and I think to build on RP's earlier point, a lot of our learning is from the visual domain, right? It's not from text. It's like, and it is through actual intervention. Like I'm looking at you now. I look at it this way. My brain expects to see the same image with a slight change. If that doesn't happen, some learning happens, right? Today's learning, where you're just trying to predict the next token, doesn't have any of those properties, right? So one can question whether you'll even get to true AGI this way. I mean, I would personally not work on super intelligence with AGI, right? Just sort of try to do useful things that actually move the ball forward meaningfully, right? I think that's really what I would focus on rather than, that's my personal bias, but there are other people who think differently, yeah.
I see, but whatever you're seeing in the last few years does not kind of make you think that the speed is fast and maybe things will happen.
I don't think AGI is imminent by any means, no. But famous last words maybe. Okay, thank you.
If any student is willing to ask a question, we'll take a question from them as well.
Looks like they were really excited having Sir's talk, but thank you so much, Dr. Padmanabhan. I would request Dr. Siddharth to join us on stage and present a token of appreciation to Dr. Venkat Padmanabhan. Thank you, everyone. I would now request everyone to proceed to the Bharati Academic Block, which is the room number 1002, for the first oral presentation in language models and translation. I'd also request all students who are enrolled in the Emerging Trends in CSAI course to please ensure that you record your attendance before leaving. I would request all ushers to also accompany their respective speakers for this.
Same kind of structure, like easier question, then on same concept we had a medium level difficulty, and then we added the other like complexity level, like higher concept, but concept understanding starts from easy, medium, hard, and there is additional concept stacking on that. So we divided data set in different level of complexity. GSM 8K and math was our benchmark data set. GSM 8K is mostly easy question, and math has medium and difficult level of questions. So we divided the math data set, and we added our data set with Indian math data set and other the easier question. We augmented these data set, and then we divided them into different level of difficulty. So this is the idea of decomposition strategy. As you can see in the image, like if there is a unit and how to decompose this larger number and how to do the computation. So we added these steps for division and multiplication, and this were able to improve model error rate in terms of computation. So all the smaller computation error, we were able to like improve on that. This is the structure, solution, design. So this is the structure we wanted to teach the model, how to identify the data, how to understand the problem, then what are the different problem theory they need to understand to solve this questions. So what are the different concept model needs to understand and decided on that? What are the different method to deal with the problem? And then last, how to do the better computation, the decomposition strategy help here. And then go to the final answer. Then curriculum learning divided problem into easy, medium, hard, and then I extended this work on 10 different level of complexity. Work was basically largely inspired by Benju's work on 2009 paper. He explained like if we teach the model in curriculum style, there is a possibility of improvement, and we wanted to improve on that. Bilingual setting. So we added more than one language for same kind of problem. An idea hypothesis was if model understands the same concept in more than one language and does not overfit. Then we compared the results for English and Hindi dataset. So we did evaluation like same model trained on English dataset, same model trained on Hindi dataset, same model trained on combined dataset, and we were able to improve on these settings. So bilingual setting improved a lot, and we were able to compete with Gemini 1.0 Pro at that time. It was the state of the art, one of the state of the art closed source model, and we were able to improve on all the open source model. We were able to compete with Wizard 7 billion model with like Gemini 1.1 Pro, and possibly like we don't know what is the size of this model, possibly more than trillion parameter, and we were able to compete with 7 billion parameter model. And main idea was are we able to improve the open source model using these ideas, and we did the evaluation. So in all of the occasion, model performance improved after adding these ideas. And we also tested the bilingual setting. So idea was if we add Hindi language, does it decrease the performance of English model on English dataset? And if we add the English dataset, does it decrease the performance of model on Hindi dataset? But we were able to combine both these languages, and we were able to improve in bilingual settings. So if model trained on bilingual data, model performance also improved on English question answering, and model performance also improved on Hindi question answering. This is the basic idea that all the teachers know. Like if if student has bilingual setting in the teaching, their reasoning capability improves. So this we did evaluation study on decomposition strategy. In all of the occasions, we were able to improve on the error rate on computation errors, and decomposition strategy helped the model. Thank you. Any questions? So we also checked because we also added our data set, so that is the combined data set, and possibly these models have not seen the Indian context data set. So that's why we were able to compete and beat them, because Gemini Pro we were not fine tuning and our model was fine tuning.
I have a question here. Could you elaborate on the embeddings which were used?
So like we started with the Wizard 7 billion parameter model, and we started with pre-trained model. So the embedding of these models, we started with that. So we did not work on exactly the embedding space. We started with pre-trained model, and our performance was only on SFT, like supervised fine tuning. So we started with like initial like in these organizers, there were some work available from software engineering company, and then we also improved like we experimented with different tokenizers, and we fine-tuned our own tokenizer.
Gemini is performing better than the hard.
Yeah. So
what is the reason for that?
Like we don't know, like we cannot do the analysis on Gemini's understanding. Our idea was we still have very low number of hard questions that we introduced to model, and these models are trained on everything. So we don't know like how these models like trained on understanding, but we had very few number of hard questions, and our
How many the number of samples?
yeah, around 1,000 hard questions, then
And for easy, how many were there?
sorry,
For
easy like 3,000 easy, then 5,000 medium, and then 1,000 hard questions.
So you have a conclusion that when you train it on bilingual, the performance is better. Yes. So does it also reflect on anything to do about any work is available to say that how does it similarly to work on human beings, or is it only purely an AI concept that you are
Yeah, so like, yes, sir. So like a lot of the hypothesis that if student is bilingual, like 2-3 language, student has overall performance increment in every field. So that was the initial hypothesis I took it from. I also tried to check the model's performance, how many like language we add and model performance still improves. So 3-4 language. So hypothesis in real world is like if we teach student like 3-4 language, like student is multilingual, their overall performance increases. So my idea is like if we teach students in concept in more than one language, so language understanding has something to learn. Student has something to learn in real world, and concept they can revise. So that was the hypothesis. So in real world hypothesis, student is multilingual, their overall performance is better, and like model also check how many languages they can handle. So multilingual 3-4 languages, and that is also like normal hypothesis. Student can perform better at like 3-4 language understanding.
That's not the NEP conclusion.
Yes, sir. Yeah.
But I think LNA, they have trained with multiple languages.
Yes. Yeah.
More, I think it's an open source model.
Yeah. So this work is published like in Jan 2025 and like 6 months back. So my work is like 18 months back. So this work I developed. So yeah, there's a lot of.
This was actually, I mean, it was presented in last year's ICCB.
Yeah.
The work on Molmo.
Yeah.
On multiple languages.
Molmo was also multilingual, multi-model or?
It had multiple.
Yeah.
Just a continuation of what Professor Bala was asking. So usually when students learn a couple of languages, it sharpens their analytical ability. That's the foundation, right? And that's why they perform better, right? They're analytically better. But that does not carry over to AI, that it's analytically becomes better. It is, for it, you have different kinds of tokens. That's all. It can't distinguish what token is what, right? So, what is the basis for better performance? I still don't understand.
Yeah. So, like analytical skills. So, as Mem was asked, so we were trying to train the model on like revise the model, same concept, without overfitting the model. So idea was if there is more than one language, model has something to learn in terms of tokenization and each and every step. So language complexity understanding. So model is revising the same concept, but it has something to learn. So model has some loss propagated through the training part. If we revise the same question in English, then after some time, after some report, model starts to overfit. Model does not have to anything to learn, and model starts to learn the question and that process. And if we have more than one language, model has something to learn in terms of tokenization and all those parts. So there is some loss propagated in the network. So that's why model still revise the concept, ideas, and then model still has something to learn. So model does not overfit, tries to understand the concept. And then combining with curriculum setting. So we start adding each and every level of complexity at that level. So combined training part, curriculum plus multilingual improve the performance. So ideas model has something to learn, and model does not try to remember it.
So my question is that all these are under zero shot setting. Have you tried COT kind of?
Yeah, this is zero shot setting. I have another paper accepted this year that has COT setting and then 3-4 language, and then this is a vertical curriculum, so easy, medium, hard. I also added the horizontal curriculum like step-by-step understanding. So model, so all these will be published in this year AAAI, and one is EAS. This is zero shot.
Last question, and then we move on to the next presentation, please.
So my question is just on data distribution. So when we are saying that bilingual is added to that, so is the data set the combination of two languages? That means 2x of what we trained earlier, or it is stratified to create the same number of samples in time frame. And second question is just on the text data, is the test data is also made bilingual, or test data is kept to the single language?
Yeah. So data is 2x means same question is given in Hindi and English plus. So that's how you are hypothesizing that model has something to learn. And then we did evaluation in Hindi, English, and then combined also. So test has both, but evaluation is done on Hindi, English, and then combined. And data was in both languages, same concept.
So data was twice.
Yeah. So idea was like checking model does not overfit, model has something to learn and improves on both of the languages.
Thanks, Dr. Yunas. That was a very insightful presentation. You can see the kind of interest it evoked for the first session. So those who are still waking up from the cold slumber, I guess that stimulated us quite a lot. I think there'll be more questions which we can handle offline just during the coffee and tea breaks. So let's move on to the next talk. Our next speaker is Sanjeev Singh, who is a third-year PhD student at IIT Kanpur, working under the guidance of Dr. Ashutosh Modi. His research centers on developing AI tools for Indian Sign Language, spanning translation, recognition, and generation, with the broader goal of supporting the deaf and the hard of hearing community. Today, this talk will explore new methods for improving how AI interprets and translates sign language. Please let us welcome Sanjeev Singh.
Hello everyone. Am I audible? My name is Sanjeev Singh, and today I am presenting our work on sign language translation. The title of presentation will be Pose Speech SLT Linguistically Inspired Pose Stitching for End-to-End Sign Language Translation. This work has been done by me and Abhinav Joshi, Venkat Padmanabhan, and Dr. Ashutosh Modi. And this work has been accepted at eminent 2025. So now, before going through my work, I'll give some brief overview on sign language. So sign languages are primary means of communication of around 70 million deaf and hard of hearing people worldwide. And we think like sign language is just a hand movement, but sign language also have hand shape and facial expression and body posture. So just like spoken languages, sign languages do have their own vocabulary and grammar. So just like if I wanted to say let's discuss, so in English I'll say let's discuss, but the same thing if I wanted to speak or say in sign language, then I'll first sign the word discuss and then let's. And another example could be, I can give that like if I wanted to ask your name, so in English I'll just say what is your name, but in sign language I'll say your name what. So here we see like there is a ordering difference in English and sign language. So and there are some non-manual markers also that plays crucial role while deciding the grammar of sign language. Let's say if I wanted to say you go with a natural phrase, then it will be treated as a statement like you are going. And the same thing if I wanted to say, if I'll sign with my eyebrow raised, you go with my eyebrow raised, then it will be treated as a question. Are you going? So as we know, like India is a linguistically diverse country, and according to 2011 census, India has around 121 languages with at least 10,000 speakers. And from an estimate, in India there are around 1.1 million, people who use a sign language. But sign language was not part of any of these surveys. And similar way for the technology. Like for Indian languages, like we have a lot of tools for translation, transliteration, automatic speech recognition, text to speech, and we have a lot of large language models for other Indian languages, but there are no such tools available for ISF. So like our aim is to do some work on sign language to empower DHS community via technology. So, so in this work, like we aim to build some tool that will translate sign videos to English text, and but it's not that much easy because like for for other spoken language we have a lot of tools, and we do not have such tools for sign language. So why is that the case? So ISL has their own linguistic and computational challenges. Few of them, I'll discuss few of them here. The first one is the structural difference, like manual and non-manual parallelism. So ISL uses different multiple body parts to convey information, unlike sequential nature of spoken language. So, for example, if I wanted to sign run, so I'll use my hand, and with the I'll use my both hand and the movement of fingers as well as the facial expression. So, like there are a lot of things involved when I wanted to sign some word or some sentence. And the other thing is that, like we have discussed, like non-verbal markers play an important role in grammar. So, let's say like if I wanted to sign happy, so I'll sign happy with the smiling face. And if I wanted to sign sad, so then I'll sign the word sad with sad expression. And the another thing, another linguistic insight for ISL is use of space in ISL. So like signers use their front space to convey time and location or manage references. Just like if a signer wanted to sign aeroplane, so the signer will use the upper space of the front space of there. And in the similar way, if signer want to sign car, then he or she will use the lower space. And the next thing is the finger spelling and co-reference. Like in sign languages, we often assign short form. Just like, for example, if I wanted to, like in here the discussion, there is a girl named Neha, and in the first time, if I wanted to, or signer wanted to talk about Neha, he or she will first, at the first time, he will sign all the words in N-E-H-A, and in the second time, if I wanted to refer Neha, he or she will use only female plus Neha, female plus N word. So in that way, we will assign short form, like and we assign the short form using some object also, like I'm using specs, so some signer can assign my name with this specs signer as well. And another thing is that, like we have discussed, like sign language, is just like English or Hindi, and sign language has grammar. And sign language USA sign language, and sign language is spoken in India, Indian sign language. So in India itself, there is a lot of variation in the sign language. In India, the sign language is spoken in north, and sign language is spoken in south. It's a bit different. There are around 25% vocabulary mismatch in both north and south region. And there is another thing is that, like use of extended uses of verb, and just like we say, like there is one. Sometimes we say that, like there is one sign associated with one word, but it's not true. Like for like the sign of a verb changes with respect of object. Just like the sign of open is like open, and then if I wanted to sign, like if I wanted to convey the opening a drawer, then I'll use opening a drawer like this. So this is a challenging thing because, like the sign of same word changes with the respect of object. So that's it. It is also a challenging thing. to process sign language. And now after discussing a lot of challenges, our task is to translate sign video into English translation, in English text. So our main contribution is that we proposed a post-stitch SRT, a linguistically inspired approach for synthetic data creation. Like we are creating a synthetic data for sign language, and retained a simple transformer model to check whether our approach is working or not. And we got around 4.56 Blue 4 score and American Sign Language data set, and we got 3.43 from previous benchmark was 0.55 Blue 4 on iSign data set. Indian Sign Language data. So like I have discussed a lot of challenges that are associated with the sign language, but the major thing that one of the major challenges that we do not have that much data. For example, we have for text translation we have around 10 million sentences for English to Hindi data set, and around 22.5 million sentence pair for English to French data set, and around 50,000 hours of audio for English to speech text, English speech to text data set. For as of now, for American Sign Language, the largest available data set is of around 984 hours of video, which contains around 610k sentence pair, and which is an American Sign Language data set. And for Indian setting, we have an iSign data set, which has around 252 hours of video and 118k sentence video pairs. So to mitigate the problem of data scarcity in sign language, we developed a synthetic data generation pipeline. So for generating, we generated 4 different data sets for this task. So let me give a brief about how we have generated the data set. So initially we have 3 data sets. Kistler data set, which is a word level data set, which is for Indian Sign Language, which contains around 4.7k unique vocabulary, and WLSL data set, which is for American Sign Language, which has around 2k unique vocabulary, and the BLIMP data set, which is an English data set, which contains around 4.k unique vocabulary. And the English data set has their linguistic features, like whether a word is noun, pronoun, and there were around 196 features for English data set. So what we have done, like for the Kistler and WLSL, we have a sign video for each word. So and we wanted to generate sentences. So what we have done, we took the intersection of Kistler and BLIMP dataset and got 504 words that were common in Kistler and BLIMP dataset, and similar thing we had done for the WLSL dataset and got 508 common words in that scenario. So and then there is one paper BLIMP, in that paper, like they have proposed 67 different linguistic phenomena, like 67 different linguistic phenomena, and these were the templates for all the 67 phenomena. And using these templates, we generated sentences, and we took the vocabulary which were common in both Kistler and BLIMP dataset and WLSL and BLIMP dataset. So in that way, like this is the overall data generation pipeline for our task. Like we have generated dataset using 2 approaches. Like one thing that I have discussed is from the BLIMP, and another thing is that we took the translation dataset, BPCC dataset, and selected the sentences, only those sentences where we have around 90% vocabulary matched with the Kistler and WLSL. So in the first approach, we generated 2 datasets, BPCC ASL and for American Sign Language, and BPCC ISL for Indian Sign Language. And in the second approach, when we were using BLIMP template for generating dataset, we generated two more dataset, BLIMP ISL and BLIMP ASL. So after generating the sentence, like we have generated a sentence like I hope you are having fun, and we have the each word video for every word. Like we have a video for I, we have a video for hope, and we have a video for having. Like here I just wanted to say, like we at some time it's not guaranteed that we will be having video for each word. So let's say we have a video for each word in a sentence, and then we extracted the key points from the video and concatenated them and formed a continuous post sequence. For like we have a word level data set, and now we have a continuous post sequence of data set. And here one more thing, like we are following the English grammar rules here, and just to check like whether there is any underlying relationship between sign language and English language English language. So these were the dataset statistics. We generated 4 dataset BPCCSL, which were around 1.6 million content, 1.6 million sentences, and BPCCSL 1.1 million sentences, and BPCCISL 22 million sentences, and LIMP ASL 2.8 million sentences. So this was our overall pipeline. Like we have generated dataset, and then we have a frames for each word, and then we extracted the key points, and then we stitched the video of each word and form a continuous sentence, and then we selected key points from face, hand, and body, and then concatenated the post vector and passed into a simple transformer architecture. And here, like it's intentional, we were using simple so these were our results. Like we got around 2.35 improvement on I sign and 2.88 on how to sign, and these are our future research, and these are our paper from on sign language. And we are also conducting a workshop on the sign language at IIT Kanpur. Please feel free to attend if you are interested. Thank you.
Like, why is the sign language spoken in one part of India only 25% in common with another part? Like, is it the underlying native tongue of the person?
Yes. We can say that like there is no such type of study has been done, but the vocabulary mismatch is there. Like when we look into the vocabulary, like few things, the sign of few things are different in north, and sign of few things are different in south. So like there is no standardization is available. ISLRTC is working on that. Like the government has set up a ministry on 2017 itself. So like we are working to standardize ISL.
The data sets you use for training for this. Is it a standardized recording, or it was just sign language being used in different contexts that were put together as a data set?
So for the training, like we have generated 4 different data sets using post-stitching approach. Like we have a word level data set, and then we generated sentences using linguistic templates, and then we concatenated each word from the word level data set, and then form a continuous sentence. So this is our training data, and then we have 2 more data sets. iSign, like iSign data set is for Indian Sign Language data set, which has around 1.8K sentence video kits that were scraped from YouTube on ISLRTC channel and video. Like we have done some manual verification as well with the signers in the collaboration with ISLRTC. And another data set was how to sign. Like and how to sign data set was recorded videos. Like this is of American Sign Language data set.
So if you concatenate from word, the hand movement is not the same. So your concatenation process, does it take care of the
hand movement? Like just say like there is one word. Like aligning, we can say like
it's more
transitioning from one word.
Transition.
Yes, yes.
It's also sensitive to that, or it is pure concatenation?
It's pure concatenation, because like we are not sure like whether this will work or not. Like we can look into that. Like we have few signers. Like they were also pointing out that like we are following the English grammar rules that is different from English like sign language grammar. So like here we were just testing like there is some assumption, like there is some relationship present between English language or between English language and sign language. So like our results, like from our result we can say that like there is some underlying assumption is there, but yes.
One more question is like you said, in addition to this movement of the face, the facial expressions also matter, but
yes.
that doesn't get captured when you're taking the pose.
Yes, from the pose it's captured like.
I'm taking the facial key points also.
Yes, sir, I'm taking facial. Yes. The majority of the key points are like we were taking 152 key points, and around 70% key points were from the face.
And then one more question, like what's the positional embedding that we see in the transport?
Just positional embedding, rotated positional embedding, like we have used.
Okay, Sanjeev, before I let you go, one very quick question. Is Indian sign languages and English, do they have something in common?
That is what we are checking, like from our.
No, in the sense that can there be kind of common processing for both the languages and will it translate to output in different languages?
Yes, like when we like here we are working on Indian sign language and translating into English text, but there is some like the same thing we do for the Hindi. There are some differences. There are some differences. Like
maybe I'll get you. Thank you so much for a very insightful talk. So I want to ask the audience, how many of you have seen this film called Human in the Loop? How many of you have heard about it? Some people have heard about it. Well, I would strongly recommend that you watch it. It's available on Netflix. And the reason why I thought of that film, because it deals with tribals in India. And it's a film about how tribal people were involved with labeling data for large language models. So, of course, that's not the topic of our next presentation by Pooja Singh. He is a PhD scholar at IIT Delhi, specializing in multilingual large language models and new low-resource languages. Her research interests include machine learning, NLP, graph machine learning, and LLM alignment, with work spanning healthcare applications and multilingual energy. Today, her talk will focus on developing and utilizing cross-linguistic datasets to improve translation quality for languages with limited digital resources, which is the case for tribal languages in India. And so please join me in welcoming Pooja Singh.
So hello everyone, a very good morning to all. So I'm Pooja and today I'll present my work on tribal languages, Abhili. Abhili is a tribal language and it was recently accepted into the eminent. So first let me check how many of you are aware about low resource languages or tribal languages in India. Can anyone please raise your hand? I think no one. Okay, so low resource languages are the endangered languages. Like they have sometimes they have no scripts, no grammars, very less digital footprints, no literature or very few literature. The range of speakers is also from few lakhs to millions. So why we just care about the low resource languages? Since we are living in India, that is a country is known for its diversity, its multilinguality and the different cultures. Even yesterday when I just entered into Chandigarh, I have seen the different boardings across the road. This all are in the Punjabi. it itself just represent Chandigarh. So whenever we just exposed to the different states across the India, we just also exposed to the different cultures and the different languages. For us, we are able to connect with those with whom we are able to communicate well. So why should we focus on tribal languages? So when we talk about AI inclusivity, it is very important for us, the people coming from the different communities across the different regions of the India should participate to curate the data set, build the models. And here in India, we have 1900 plus languages that is spoken across the different regions of India, out of which only 22 scheduled languages are recognized by our constitution. So what about other languages? And apart from this, there is completely untouched language, that is the tribal languages. Around 461 languages are spoken by the different tribal communities and having the speakers range from the 100 millions. So let's have a look on the different AI language models that support the machine translation. Since my work is primarily based on the machine translation, we should focus on it because whenever you just travel across the different regions, you should first have a medium to communicate with the different peoples across this region, where the translator comes into picture. So Google Translate mostly supports 243 languages across this, very few coming from the tribal background like the Santali, Bodo, Khasi. When we talk about Microsoft Translator, it supports around 22 languages, that is primarily the scheduled languages. And there are a few initiatives like the Bhashni, Indian tools coming from AI for Bharat, it's a startup from IT Madras, and Anuwari. They mostly support the 22 scheduled languages. And here, as we can see in the table, like near the Bhili, around have the 32.4 million speakers. It's sharing the Devanagari scripts and spoken across the different states of Madhya Pradesh, Gujarat and Rajasthan. It's also sharing the lexical similarity with Gujarati. There are a few other languages that is spoken across the different regions of the country and also have the prominent number of the speakers. So before building the language models, we would need the data. So with the tribal languages, we have one problem, we have no data. So how we should create it? To build the data set, we just have reached out to different tribal research institutes where we pick the different native speakers who have an experience of 10 to 15 plus years. They are mostly have the teachers and professors because just in the initial stage of building the models, we need a very valid data, accurate data to make the authentic models. We also have organized the different workshops where we just train the different volunteers because there are different translation guidelines. Let's suppose if you have a day 2005, you need to translate it. Someone have translated it 2005 in Hindi and someone have translated it 2005. Someone translated into Hindi itself like 2005. So there are different things. We should keep consistently across the different terms like NER. And then we also organize the different kind of community workshops like where the different native speakers coming across the different regions and they can write the essay on the different topics where we also just help us to create the data set. So to validate the data set, what they did, we train the model, whatever the output the predicted by the model, we just give it to the native speakers, they just validate it and then we use it in the retraining of the model. This step is very important because we cannot rely on the automated evaluation matrices because we know that most of the evaluation matrices is specifically designed for the high resource languages. And this to work on the tribal language is also very important because when we talk about AI inclusivity, it relies to the education, healthcare, different organization or different schemes that was made by the or facilitated by the government for the tribal languages because we have seen like the different AMRS scholarship, especially for the tribal peoples, they did not understand it because it is mostly in English and Hindi and that they are not able to participate in it. And similarly, the tribal kids, they also drop out from the school because they are not able to understand this primarily the languages like the Hindi and English. So how we can teach them in their own languages. This is a few sample of the data set that we have collected. We have done the pre-processing on the source sentence, that is Hindi. We use the Indicans 2 model to translate these Hindi sentences into English language. we just kept the sentence length from 6 words and less than to 80 words, just to make the model to learn the different contextual dependency and semantics of the language. So we range from the different domains of the data set, that is coming from the NCERT books, its teachers, and the mass media data set that is primarily just included from the Bharat Ballot Corpus collection. It is the first benchmark study and the first data set that is around 27,000 hours, and at average of 10 speakers, every day they work on the data set around 6 to 7 hours. They translate the Hindi to Hindi, and for just to make the model for English to Hindi, we just use English as 2 model, and then we also did the careful proofreading for the English translation. This is the statistics of the data set. We just have 1,08,000 data in the training set, and then the rest for the training and evaluation. Since so far we have seen the process, it is very slow. Every time we just give the Hindi sentences, they translate it and then type it, and then we use for the training the models. So how we can make it too scalable and fast? So for this, what we did, we have an initial state purpose. Like suppose 18,000 of the data set was built, then we train the model. Then we save the checkpoint. Then what we did, whatever the next Hindi sentences, we just inference this using the save checkpoint, and we just get the translation. We send this initial translation to the native speakers, then they just validate it, and then we just incorporate in the data set. So it helps us to scale the data set, does not going from scratch translation and typing. So far we have seen how we curate the data set, how we scale it. So let's have a look on the different existing models that support the translation of the multilinguality. When we talk about the machine translation models, specifically seek-to-seek models come in the picture where they have encoder-decoder architecture. And when we talk about LLMs, the decoder family comes into the picture, especially from the GPT, Gemini, or Bloom's family. They are mostly dominated by the high-resource languages. Even the Indian languages that we consider high-resource, Hindi, Marathi, Gujarati, they are low-resource for them. These are few research questions that I have explored in my paper. First is, how the existing multilingual models can adapt to a language that is coming from the especially low-resource background. Since the village is sharing the Devanagari script and also having the lexical similarity with Gujarati and Marathi, these are the highly resource languages. Does these models have a positive transfer to these languages when we fine-tune them? And the next question is like, if we do the fine-tuning of these models, and what performance we can expect in comparison to the context learning, like in the zero-shot setup or with the few-shot setup, and how the domains will affect the model quality across like NCERT books or the news. For the evaluation purpose, along with the automatic matrices, we just also used human evaluation, like there is inter-annotator agreement. I will explain it later. Direct assessment scores. Some of the evaluation matrices, like automated one is like CHR++, and SQ Blue, it is just at the very end of the blue. And we just evaluated the model across the different translation direction, like Hindi to Boolean and reverse, similarly for English to Boolean and reverse. For in context learning, we just having comparison across the 0 and 5, 10 short. So the most dominant one are the closed source model that is coming from the GPT family. And then we can see here, as soon as the number of examples is increasing from 0 to 5, there is significant improvement across all the models. But from 5 to 10, there is saturation in the results. Across supervised fine-tuning, apart from all these models, Indictance 2 is a model that is completely trained on the Indian languages. Since this is a model that is trained on 22 languages across the different 421 permutation and combination of these languages, it seems to be saturated on this 22, and so it's not able to generalize well on the BE. Here, NLLB model performs well. It is the no language left behind model, 600 million parameters. It's a Facebook model. Just to check the cross-domain adaptability of the different models across the different domains, like the NCERT use mass media data sets. We just use the Jensen's and divergence just to the model performance is so all the maps we have seen, like across the diagonals we have the highest scores. have the model outputs like the 250 sentences per direction. We use two annotators. They seated across the different rooms. We have given them the Hindi sentences. They translated using few translation guidelines into respective like Hindi language. And after that, we just do a kind of correlation matrix like is inter-annotator alignment. So we found that like the CHRF is closely similar with the human judgment, and where when the Hindi is the source language, the model suffers a lot because it suffers while capturing the different nuances or semantic of the language. Whereas when the target is the Hindi and English, we are able to predict well, and the performance is very high. So apart from this automatic matrices, it is not sufficient. They still have to work to build some evaluation matrix that is specific to lower source languages to capture the nuances. There are different NLP analysis. Even the NLP perform is very well, but still it has a few errors. Like it simply mix the language or few words of the Hindi English with Gujarati. There is still hallucination problems, and sometimes the models omit some important things, or sometimes they just replace with another meanings like contextually irrelevant things. So this is the research outcomes that is we are revisiting our hypothesis. First thing, like script similarity is not enough. We have to come with different models that is specific to the lower source languages just to understand the semantics. Fine tuning is a good approach. Since we only have the parallel corpus, we are not able to use like the unsupervised approaches. So for this, better than in context learning, fine tuning is good. And then across the domain and distribution hypothesis, we have found that like domain adaptation is a difficult thing. Whenever we talk about the machine translation model, we should keep in mind that what the domain we are going to test it. Because some like conversational domains is always tough for the model to understand, but it is performing well on the education data. So this is the limitation future work, and that in future we were planning to work on some unsupervised approaches along with back translation. Scale the same approach to other lower source languages and to build a single model with the joint fine-tuning approach for all the tribal languages. And the limitation including like we don't have a monolingual corpus, we are in the process to curate it. So since this work is a part of Adimani project that is initiated by the Ministry of Tribal Affairs, and this work is also turned into the deployment that is a tool named Adimani. This is the India's first AI-powered translation tool. It's available on the Play Store website. This is in collaboration with the different institutes and tribal researchers. And thank you.
So we talked about the tribal languages. Are there special characteristics compared to the other spoken languages which are spoken by much larger people?
Yes, sir.
Yeah.
That's why we suffered a lot, because actually it shared the similarity with Hindi Gujarati, but while doing supervised fine-tuning of these models, we have seen like, I can say, the way they speak or the way they write is little different. Like school, we write something different, school in Hindi, they write E in the front of it. And similarly the greetings, I can say like, they simply tell Johar for all the greetings. Good afternoon, good evening, and for us, this is a different things for the different time zones. So similarly, there are much more things where they are using some different terms, and that is semantically similar, but we using some different terms with respect to different sentences. So yeah, there's different.
Do you have any comments on why Fine Short was able to give significant improvement in the performance, that it was saturating the writing?
Actually, it's consistent with the literature. Like I have also seen with the zero shot, it's not able to capture the nuances or the semantics of the languages. But when going to 5 shot, like few examples, there's a boost in the performance. But 5 to 10 wise, I don't have its answer. Like I'm not able to interpret it.
Yeah. So my question is. That's what, yeah, it's really good to see this kind of work. I think it's really important. But to make this the interaction, right, attention to other languages. Is there unique knowledge that is, in the tribal communities that we can unlock in these laws? Like, using tribal languages into the form of LLMs, are we able to unlock information that otherwise would not be accessible to the rest of the world that does not speak that language? Right? Have you sort of looked at that aspect? Is there knowledge that
so they come with something like they completely happy in their own ecosystem that I have seen so there are a lot to learn from for us from them, because I have seen for coming from their medical thing or other things, they have their own solutions that is completely very good, means we have to adopt it.
Exactly. So that kind of knowledge is unlocked.
So we are in touch with community speakers. We are still in the process to adopt it more.
Yeah. I guess what I'm trying to say is going beyond the language. Language is an enabler.
Yes, sir. Yes.
But ultimately, if you unlock knowledge that is not within this tribal communities today, you can get a lot more attention.
Yes, sir. Actually, there is one center for rural and development. It is working in collaboration with this TRI, Tribal Research Institutes. So they are working on all the different aspects. Apart from this language, they have very much rich culture. Very much, they are rich in almost all the terms. We are mostly shifted towards the Western culture, but they have their own pure natural things to preserve it. So we have to learn and adopt from them. We are in the process of that.
Hello ma'am. So I understand that this problem was aimed at, the solution you built was aimed at solving the issue of translating from a very underrepresented language into a language that's more commonly spoken. And I'd be led to believe that getting the data would be one of the most difficult parts of this. So what were some of the practices you followed to ensure that you didn't get a lot of bias or a very short amount of data so that you could actually train the model properly?
So few is, so I will mention the few. So initially we just give them the Hindi sentences, they translate it. One is things like text to text translation. We also have built few tools like for crowdsourcing option, because there is a lot of noise will come when we give the option to just upload anything to them. So initially we just pick a few volunteers. So we also planning to give them some incentives, like they just give their own folklores, their stories, their literature, they upload it. Then later on we have also built the OCR, like Adimani have the different features, you can check out the app. So using the tribal OCRs, we can extract the text, and we are also working on the automatic speech recognition. So very soon it will work on, then we just also able to capture their audio data.
Thank you, Pooja. Very, very impactful work, given that this is an area which really needs all of our concerted efforts, and I'm very happy that we have such work among us today. For the next talk, let me please invite our final speaker for the session, Suvendu Khadua, who is a PhD student and a Prime Minister's Research Fellow in Computer Science at IIT Kharagpur. His research spans NLP, large language models, and information retrieval, with a strong focus on financial text analysis. Today's talk will cover new approaches to efficiently adapting large language models for specialized tasks in financial domains. Please join me in welcoming Suvendu Khadua.
Good morning, everyone. So today I am going to talk about two applications, and these are related to financial domain. So first one I will talk about extreme financial numeral reasoning, and next one I will talk about financial reasoning. So Security and Exchange Commission has already mandated all the public financial companies to report their financial statement in a specific language called extensive business report language. So if you read out any of the financial documents of any of the company like Goldman Sachs, you can check they are reporting some numerals into a specific tag. Like what is it there? For example, $192 million has been tagged with some paying interest here and straightforward. Within an input financial statement, you have to identify the relevant numerals which needs to be tagged. So there are some numerals you don't need to tag, you need to tag by others because those are not relevant. So your first task is to find the relevant numerals. Then you have to give the appropriate tag for that. So we collected 10K annual documents from 2019 to 2021 from SEC websites. So the dataset contains data of 2,300 companies and it contains around 79K sentences with 1.42 million annotated numerics. So the number of possible labels can be one of the two labels. As you can see in the right hand side, this follows a long-term distribution. So you have many instances where you have only data points less than 20. Now why this is a challenging problem? So I have given few examples here. If you see the second example, which have very simple 7 numerals you have to tag, and all of them are different. Including you have some numerals, this is not relevant, you have to tag by others. If you see the example 3, there is no correct pattern. It is not like that if this is percentage, it should be tagged with others. But if you see 75% is tagged with some financial tag, where 25% is tagged with others, which is not relevant. So compared to the traditional linear kind of task, like numerical labeling, if you see the number of entity types, this is very huge. Like ONLL datasets only 4 entity types, and you see the final 139, which is the similar kind of problem they solved. They had only 139 tags. But in this task, we have 2,794 labels. So the problem is here is you have very limited context, and sometimes if you see this example, the 2.49 numerals compensation, liability, current and non-current, but if you read out the sentence, you may not correlate with the workers' compensation liability context. So we reached out to the domain expert who already does this labeling manually. We tried to understand how they do. So they already have some knowledge about all the 2,790 labels, and sometimes they do mistakes also. What we identified, for each of the tag, you have some sort of documentation for that. If you see the first example, the tag only differing those in the word. But if you see the documentation, that is, I think number of words are very large, and you can get better context from the documentation. So we frame the problem in that way. Instead of predicting the particular label, what if we generate the documentation itself? So this is a generative approach. We try to solve this problem. So you have an input sentence. Now we have framed some instruction for this particular task. We have supervised find to 25, but at the target level we are not generating the label, but we are generating the tag documentation. Now because it is a generative model, sometimes it may generate some wrong words, or it may over generate some words also. For that reason we have some tag matcher, so this is a two-step process. So whatever train 25 has been generated, you can simply map that documentation to all of the available tag documentation you have in the program. Once you get the correct tag documentation, you already have one-to-one mapping between the documentation and the corresponding tags. So in our training approach, we adapted the low-rank adapter, that is LoRa. So that's why this method is parameter efficient. So compared to the previous baselines, we have only 0.08% model parameters that you can simply update. So this is the main results. As you can see, we have followed the previous literature to check how our model performs than the previous baselines. For 2 datasets, one is the FNXL, the dataset that was also published in ACL 2023. We are getting very high macro precision and bit-set one, and the other dataset that is finer. But they work on very limited levels, only 139, where we are getting almost 94% macro. So these are some sort of ablation study. If we just change the tag matcher with some other sentence word or something, what happens? And if we don't use the tag metadata, if you try to generate the labels directly, you see there is a very much huge performance drop in the macro and bit-set word. And if you don't use any instruction prompt, which is very specific to this task, there is also performance drop. So it shows that you need very good instruction and the tag metadata also. Because this is a generative model, you can get advantage of the zero-shot capability, which is lacking in discriminative classification task. We are getting almost 58% 9.1, which is not too much, but it has the zero-shot capability. So as obvious, you have to compare with the ChatGPT, because you might think that this is a very straightforward problem, but ChatGPT is doing so much mistakes in the generations. So for an example, if you see the ChatGPT generated estimated fair value, but the actual tax should be long-term rate fair value. So we did some error analysis. So the problem is even a minor variation can lead to a very wrong predictions. So let's say we predicted from other party, but the actual should be to other party, only a word difference. We predicted, let's say, dividends paid, but it should be dividends declared. In financial terms, both are different. So in order to solve this problem, in future we are planning to incorporate some external financial knowledge as well. So this is the first one that got accepted in April 2024 last year. So the next application I am going to talk about, financial numerical reasoning. So here the problem statement is also not very straightforward. You have a financial question, which is kind of mathematical questions, but the context you have both the tabular and the text data, and the context is very low. So for an example, if you want to solve this problem, what percentage of total debt was long-term debt in 2017, if you see the relevant information is only the second row in the table and only few sentences in the text. So we worked on public data set like FinQA and FinQA. FinQA have 147 difficult test examples. So our proposed methodology is like this. Because there is a very long context, first we wanted to identify very relevant information that we can extract from the both table and the text data. Now what we are doing, given that relevant documents, we are trying to find out some in-context examples. So here the in-context examples will propose that it should be dynamic and it should be diverse. So for each of the financial questions, you cannot fill a static in-context example. So we are adapting one reinforcement learning framework for getting dynamic in-context example, which is from policy gradient. But what we are ensuring, while we are just generating the in-context example, first we are trying to get some diverse set of candidate examples. So in finance, you have a lot of topics, like one can be dividend, one can be growth, one question related to the percentage change. For the reason, from the training purpose, first we identified some representative questions. Then from this reinforcement learning framework, we are just starting with the diverse candidates just to get the dynamic in-context examples. Once you give the relevant information from the text and table and give the dynamic in-context examples, we are taking help of the GPT-4, and here we are using program of thought paradigm. We have tried with chain of thought paradigm also, so it will generate some pseudocode in Python, then we have some external interpreter which can give you the exact answer. So this is the main result. So the baselines you can simply try only GPT-4 with program of thought, you can try simply chain of thought, you can try other prompting methods. So first is the fine-tuning based method, next you can see the Bloomberg GPT like prompting based. This is the hour method where we are getting almost 8.5% improvement in the FinQA and around 10% improvement on the conversational data set. So this is sort of addition study. We tried to replace GPT-4 with Gemini 2.0 and GPT 3.5 Trago, which just observed a slight drop in the performance. Also, the previous baseline was the Apollo 40 stars. What we did we tried our strategy like dynamic in context example, diverse dynamic in context example. We observed that the previous baseline is also getting some improvement. So we tried different prompting strategies also. Instead of giving dynamic in context example, if we give static in context example, and if we give in different order, like say if we reverse the order of the in context example, or if you select some example with cosine similarity based, then what happens? We saw some certain drop in the performance. Here also we did some sort of error analysis. So the error can be from 3 stages. One can be round truth may be wrong, the financial question that we can't do anything. Another, we identified the relevant fact we are extracting that may also go wrong. Another is the logical error. Sometimes the model is not understanding the what sign it should be, because in finance some sign is negative, and sometimes it is not understanding the what whether we should report in the percentage or the absolute number. So these are the publications. So the first work, the data set got published in ACIL 2023 and the paper got published in March. This financial reasoning work got published in eminent 2023.
So in the first half, you talked about the generator task where you were giving a tag to a particular statement or a number, why was that not a classification task? And like, what was the loss function you built for it?
Yeah, you can treat it as a classification problem. If you check the baseline, also we tried the classification task as well. Even we tried the tag documentation thing in the classification framework. Also, we tried to give that input. There is another paper called label semantics, but we got certain improvement in the genetic case. And in the genetic class, you can get the zero structure for picture also, which is the in the instrumentation.
Thank you, Shubhendu. Our students don't have a question. So let me finish by thanking all of our four speakers for giving us such a diverse set of talks. And may I invite the speakers on stage to have a joint photograph. May I invite Dr. Padmanabhan to come and give the mementos on our behalf?
First we have Dr. Avinash Anand. It's a depiction of the work that he's done and the paper that he presented, and we try to capture that. Next we have Sanjeev Singh. Pooja Singh. And lastly, Mr. Surendra. Thank you so much, Professor Harish and Professor Deepa, for organizing and chairing this session and for running the discussion over here. I would request for the students who are involved in emerging trends in CSIR, please show you mark your attendance.
Hello.
Now I would invite all of the participants to be accompanied with their respective ushers to join us in a group photograph that will be taking place outside here on the campus in front of our campus. This will be followed with a campus tour and lunch in the dining hall. Thank you. To the second oral presentation on medical imaging and healthcare applications. I'm pleased to introduce the session chairs, Professor Sandeep Manjana, and we have Professor Monica Sharma with us today. Professor Manoj couldn't make it. Just to briefly introduce both of them, Professor Sandeep Manjana is the assistant professor at Plaksha University, and he's completed his PhD at McGill University and later served as the James McDonald postdoctoral fellow at the GRASP lab at the University of Pennsylvania. Professor Monica Sharma is the program chair for the Biological Systems Engineering major at Plaksha University and also the associate professor here. She has done her PhD at IIIT Hyderabad, and her research focuses on bioinformatics and computational biophysics. I would like to invite the session chairs to begin the session.
Wanted to say something? Yeah? Did you want to say something? Or
please go ahead.
Sure. Sorry, I pulled in Monica because Manoj dropped out to chair the session. Okay, you want to come up? Or? Yeah, sure. Yeah. Thanks, Monica. Yeah, so I want to start this session with a small saying in Kannada. I don't know how many can understand Kannada, but anyway. It says, Adu muttada soppilla, Anjaneyanillada urilla. That translates to, there is no green leaf untouched by a goat, and there is no village without a temple for Lord Hanuman. So similarly, AI has percolated into everything we do and every topic that you work on, every domain you work on. And healthcare is very important, especially for India, the way we are scaling and the way the models need to scale. AI needs to play a bigger role in India, at least in aspects of healthcare. So I'm very happy to co-host today's session. So the talks in this session highlight innovative methods for improving medical image analysis, predictive models, and healthcare decision support, reflecting the growing potential for AI to enhance patient care, support clinicians, and address challenges in complex medical diagnosis and also using complex medical data sets. And today's, I'll let Monica invite the first speaker, and we have 4 speakers. We're still waiting for one of them, and we'll start the session with our first speaker.
Thank you, Sandeep. And good afternoon, everyone. Welcome back after the lunch. So our first speaker, Azad Singh, is a PhD candidate in computer science and engineering at IIT Jodhpur, and he's working under the supervision of Dr. Mishra. And he has recently submitted his thesis. His research focuses on self-supervised learning and robust representation methods for medical imaging, particularly for chest radiographs. And he has developed frameworks such as Dissect, CoBoom, many. It's really amazing. Today, his talk will cover approaches for enhancing the robustness and clinical reliability of medical image representation. And please welcome Azad Singh. Yeah.
Thank you, ma'am, for the wonderful introduction. So, today I'm going to talk about my paper, which was accepted at ICAI. ICAI is European Conference on Artificial Intelligence, which was this year organized in Bologna, Italy. So this paper is about the robust medical image representation, as we have observed that robustness is very critical and very important for the clinical applications. And as we can see that we can have different sort of distortions, like the motion blur. People can have respirations while taking the X-rays, or there can be different real-time clinical variations like the poor illumination, some sort of noise. So all of these different variations, different distortions can lead to image degradations, and we may face some sort of distribution shifts. And above all of these, we can also have some sort of adversarial vulnerabilities where attackers can damage these images, and our deep models, the confidence deteriorates under these realistic perturbation conditions. Now, like we have a couple of solutions like which already exist. Like we can do some sort of image enhancements. We can apply some sort of data augmentations to synthesize some sort of noises, or we can try to regenerate these kind of clinical distortions which we face in daily clinical activities. But these solutions are like very data specific, domain specific. We cannot generalize these sort of solutions across the different modalities or the different conditions like this. But in clinical settings, like we are having very, there are various acquisitions protocols, different scanners, and different conditions, or the patients, or the biological variations can be there, which all of these leads to a very, some sort of distortions which are very, very clinical relevant or cannot be seen in the natural image domain if we compared from the natural domain to the medical image. So what we need, we need some sort of adaptive techniques, and that is data agnostic solutions, and that can learn representations which through some sort of automation learning, and not emphasis or not through this domain level or conditional enhancement like the robustness or the image enhancements. So there is a if we want to understand like why there are some sort of different variations. So the idea, the thought process can lead us to think about the continuous representations. Our deep models learn continuous representations, and these continuous representations are very fragile in the nature. Even a small, even a minor change in the input domain, so can lead the model to give different outputs in different like input variations. So now, if we want to counter these continuous representations, we have an obvious answer, like obvious counterpart is the discrete representations. So that thought like motivate me to explore the discrete representation space in the medical domains along with the continuous space, because continuous space is really important. Our model learn in the continuous space, do some sort of inferences, and the final decisions is based on the continuous space, so we cannot ignore that, but we may utilize discrete space along with that continuous space. So to learn these quantized representation, we have a concept of vector quantizations in the code books. So a very simple idea, or the very if I want to put in the vector quantization in the very simplest way, we can relate it with this with some sort of clustering. So if our encoder is able to recognize some sort of features, and the similar features can be encoded by a single codebook vector. So like if we want to talk about in the context of lung regions, so the chest radiograph, so the in most of the data sets, like the pneumonia pattern is quite similar across the entire data set, or different patients can have similar sort of nodule or similar sort of pneumonia, or the lung structure, the overall structure is quite similar across the different patients. So we can apply some sort of clustering that help us to bring discretization in the representation space. So the whole idea is, can we represent similar sort of features with a single codebook vector, or a very limited set of representations? So you can have a better idea with this a basic framework of vector quantization. So here, like these dots represent some sort of features extracted by the encoder, and these E's, which are represented by the red dots, so they are the codebook vectors which are learned automatically during this representation space. So here, this one codebook vector E1 is representing several similar features. So this is very similar to k-means clustering, but here our codebook, this is a codebook initially initialized by some sort of random embeddings, and this is our encoder decoder space. So this is a like typical architecture of the vector quantization which was proposed in the paper of VQVA way back in 2017. So our encoder is trying to learn some sort of continuous features, and the codebook is trying to discretize these continuous features with the help of this framework. So so what we can infer from this Venn diagram is that a simple term is similar sort of features can be represented by some codebook vectors. So that's the whole idea. So the motivation behind it is something like that. The continuous features are very fragile. So if we make them discrete, but discrete features, generally the codebook vectors don't change with the minor variations in the input space. So our encoder try to interact with the similar codebook vectors if the data set have some sort of minor variations or some sort of distortions in the input space. So that's the whole idea behind this work. But so this is the simple idea, but the limitation here is that, like, the thought process behind this is that now we need to quantize some sort of features now. We come up at this stage. But now the question is, which are the features, which of the features are the most representative one which we can quantize, or at which scale, or like this is a very deep encoder network. So at which layer particularly we should do the quantization? That's the key question here. So because if we want to discretize at the very lower layers of the encoder, so the by that time the encoder is already made its decisions, or the representations are already learned. So that's if we quantize at that level, maybe it will not help us. Or if we want to quantize at the very finer level of representation, that also sometimes may not help us, or sometimes may help us, depending on the input, or depending on the distribution of the data, or depending on the modalities we generally have in the medical data sets. So that's the problem here. Now, the solution seems to be straightforward, but it's not. So simply, we are having a backbone encoder. This can be any ResNet module. So I did experiments with different sort of CNN models, and I try to explain it in very simplistic way because there are a lot of students here. So we for the experiments with for this paper, we take 3 different scales. So ZC is the coarse grain features, this is the mid grain features, and these are the fine grain features. Now for each of these scales, we are having a separate code books. Okay, so the code books, if I again want to explain it, these are the embedding vectors randomly initialized. So we are having k code book vectors, each of size d here. Now there is a term hard codes and soft codes is there. So what we took one feature of this continuous feature space, and we want to find out one particular codebook vector which can represent this continuous feature. So for that we calculate the distance between this continuous feature with every codebook vector, and we pick the codebook vector with which the distance is the minimum one. So this is the way we find out a codebook vector, a representative codebook vector for a continuous feature. Now the similar sort of continuous features will get similar codebook vector through this distance calculation method. So this gives us quantized features at different scales. Okay. Now we want to let the model decide. So which of these scales is important for a particular instance of the sample. So for that we have a notion of soft code. Soft code is simply if we instead of the argmin, if we take like a probabilistic distribution for a continuous features, like these many are the codebook vectors which can represent this continuous features with different probabilities. Okay. So here in the soft codes we not extracting a single codebook vector, but we want to estimate a distribution of codebook vectors with different probabilities that can represent that continuous features. So that gives us a soft code. In the subsequent slide, there are more details about the soft codes because that's some people may confuse in that. So based on the soft codes, we have some sort of probabilistic distributions, and the probabilistic distributions help us to find the entropy of the different of each soft codes, and with the help of entropy, we let the model to scale these hard quantized codes at different scales. So for each different instance, model can decide which scale which scale should give more importance or which scale should give less importance based on the entropy calculated through these soft codes. So soft codes are just to guide the model to choose which are the best hard quantized codes. Now the hard quantized codes, at the end, based on this entropy, we do some sort of aggregations, and we are having a single quantized representation with weighing of different scales. And this quantized representation along with the continuous representations is used for the final classification task in this. So this is a supervised approach, and we have developed a self-supervised approach with the similar concepts also. So the loss function is similar here. To do the classification, it's like simpler cross entropy loss function. And to train the codebook, there are 2 loss functions. One is the codebook loss, and other is the commitment loss. In the codebook loss, we freeze the encoder. we freeze the encoder embeddings, and we let the code book to move closer towards the encoder side. So that way, that help the code book to learn features which are already decided by the encoder. Now at the same time, we freeze the code book and we let the encoder move towards the code book. So with these two auxiliary loss functions along with the cross entropy over here, the overall model learns the continuous representation space as well as the quantized representation space. Now if we do some sort of minor modification, so there are some sort of distortion in the input space, the quantized space will assist the model to stick to its already decided representations. But the continuous space is also important to do the classification and for the model training. So that's also important. We need to keep it along with that, and the quantized space helping the model to stick to its quantized space. Okay. So these are the details of the soft codes. Maybe I just left with 3 minutes, so I'll try to finish it quickly. So this is an example like. This is our feature space. We do some reshaping and flattening. So we are having n features, n spatial features, each represented by its column dimension. And we did the quantization at the column space. So the code book is having k code words, each of size, which is equal to the column dimension in the encoder space. So this way we compute the distance with each of the spatial features with the code book, each code book vector. And to do the soft assignments, we took this softmax function over there to get the probabilistic distribution. Now the D is like it's for one feature, the code book, the code vector 1 is at this distance, and the second code book vector is at this distance. We apply a softmax over there to get the probabilistic distribution. And now coming to this matrix, this is a very simple. So we are having 4 features with k code book vectors. So this is the first feature with like 0.7 is the probability of the first code book vector which represent this feature, and this is how the code book this matrix create. Now we want to find out like this particular code book vector, how important it is. So for that we stick simple like averaging. We took this these are the code book vectors, and we took simple averaging that gives us p power k to pk to compute the entropy. So again we pass it through a softmax layer to calculate our entropy with this. So this is our pk. Like this is the first code book vector is averagely 40% of the time it gets activated, and this is the second code book vector. Let's say it's 37.5% of the time it's got activated, and this is our like least activated code book vector. Now this helps us to decide entropy. So there is scale calculations also over there, so it may confuse you right now, but if you like we can talk later on. So the idea is like the higher entropy leads it gives us idea of the more complex features, so the model should focus on those more complex features. But a lower entropy is like the feature spaces doesn't carry much information, so that scale can give less importance compared to the scale which is showing higher importance for the particular instance at the sample. So this helps us to decide like which of the quantized space give which of the quantized features give how much importance is that. Okay, maybe we can talk later on. Oh, sorry. So let me quickly give the results. So we did experiment on the 2 medical data sets. First is chest X-ray, second is skin lesion data sets. Then these are the baselines published at different venues. And these are the results. So I did experiment with different sort of CNN models. So the approach is very flexible. We can deploy it over any solutions. The idea of quantization, hard code, soft codes can be applied on at different scales, even on the like Connext and the VIT architectures over there. So we are having like decent improvements in the AUC as well as the F1 score, because F1 score is the really important in medical imaging. We cannot rely on the AUC score independently. So here we can see almost 11%, 9% jump in the AUC score, and similar results in the chest in this ISIC domain. These are the baseline comparisons. And these are the perturbations. So we are having like in this there is the data set is the clean data set, the training data set is the clean data set, but the test data set is entirely corrupted. So with without seeing any corrupted samples, the model is able to retain its performance at a decent level at different data sets. So these are the really important results. So our model is not only accurate, like able to localize the ROIs very efficiently, but it is also showing very decent confidence compared to the standard CNN architectures and the closest baseline in this category. Okay, the formatting hubs. So the future work, there are a lot of future works. We can use soft codes and the hard codes to the machine learning concept also, which is popular, getting popular these days, because like this gives us exact, we can find out exact weights which are important for doing the inference or to learning representations. Okay, so this is the way if you want to connect me or you want to read the paper. Thank you. Thank you.
Who wants to start first? Can you leave on the summary slide, maybe that will make people.
Thanks for this talk. So I had a question. You are using the soft weights entropy to weight the hard weight the top one predictions of the hard weights. So entropy measures the uncertainty. So wouldn't the sure features be more important than unsure features?
In that conventional way. Our idea is like the scale which is having very high distortions in there. So that scale represents very rich features, and model is not confident over that scale. So that scale should emphasize more compared to the scale on which model that's easy to understand. The model is already understand that scale, or that scale doesn't carry much information in that. So the idea, like the conventional idea of using entropy, that's what you want to talking about, is in the confidence when you want to boost up the confidence or doing stuff like that. But here we are trying to utilizing the same idea in reverse way. So higher entropy means there is more distortion, so that scale is carrying more sort of features, so that should give more importance while doing the final inferencing.
Okay, we'll take one more question and then.
Have you done any ablation studies?
Yes, ma'am, I did, because I was not included in this. So we did ablation study with different size of the codebook vectors.
So could you establish that this actually, this entropy scaling really works?
It's like mine idea. I discussed with my supervisor.
No. Did the ablation studies establish that?
Yes. Everything is. So if you like get the paper. Yes, sure, ma'am, sure. Thank you.
Let's thank the speaker once again. Currently postdoctoral researcher at IIC Bangalore at the Center for Data Science, and his research focuses on developing foundation models for medical image segmentation in federated learning environments. Today his talk will explore techniques for improving collaborative and scalable medical image analysis while maintaining clinical accuracies. Let's welcome the speaker.
Hello.
Okay, so first of all, very thank you for inviting me for the talk. And the thing I will be presenting is the STOCK, structural alignment based self-knowledge distillation for medical image classification. So it was actually published in a very reputed journal, Knowledge Based Systems, last year. So the story starts with knowledge distillation. So if anyone is not aware of it, so what happens is that in real world scenarios, if we want to deploy some deep learning architectures, we have a resource constraint, like we have this much memory, this much time to take inference or to deploy it. So the deeper the model, the generalization will be better. But for resource constrained environment, if we want to deploy such models, then there will be some problem. You may get long inference time, or memory may get stuck while processing it. So in knowledge distillation, what we do, we actually train a model that is called as teacher model. That is a cumbersome one, that is a deeper one, and we try to transfer its knowledge to a smaller model. We tell it as a student model. So for example, in real world analogy, you can say like a boy who is stuck in somewhere in the book, he is not able to get what the dog is. So if teacher will tell it's a dog, then he will interpret that yeah, my teacher is telling this and it's a dog. So overall, it's a knowledge transfer method as well as a regularization method, which can help you just deploying a smaller model with comparable performance. So the challenges, as I discussed, like the problem is with medical image classification. So in medical image, there is a lot of class imbalance. There is interclass similarity, like two diseases may have same kind of symptoms in some examples, or there may be intra-class variance, like a single disease may have different kind of samples which are mutually exclusive to each other. And there is obviously data scarcity, as you can see in case of COVID-19, there were very less samples for evaluation. So you can visualize it through these images also, like these actually the images which belongs to same class. This may be the dataset ratio. There may be a majority class which is having over 5,000 samples, and minority class may have only 30 samples. And you can see there is too much overlap among the classes if we map it in smaller feature space. So in earlier methods, there were some limitations, like in contrastive learning, there was sensitivity to labels. In self-supervised learning, then it actually kinds of clusters the things. So there may be interclass similarity related problems. There are other methods which are most prevalent. Those are mean teacher, self-ensemble, relational knowledge distillation, distribution-based knowledge distillation. All have some kind of problems. Those we have solved using the framework stock. So in this, there are 4 such key contributions. First is the creation of class affinity graphs. We tell it as CAGs in short form. Then there is structural alignment, which consists of 2 things. First is distance, second is angular alignment. We will discuss these in next slides. So this is overall framework. In this, we will use one model that will be a student model only, as there is the framework called mean teacher self-ensembling, which tells that if we just train a smaller model and just propagates its weights to the mean of its weights to some other model which is of same architecture, then it can be helpful while overfitting the examples. So what we did, we first extracted the feed forward embeddings and created some class representations based upon mean of the feature embeddings we have got from each of the encoder. So here we have this student encoder, and there will be a teacher encoder. Those two are actually belongs to same deep architecture, but the only difference is this model will be trained. That will be just a copy of model which is having mean of its weights. That will be floated to from this model to this model. Next thing is we will just create class centroid, and those class centroids for each data point, means for each example we will try to the model that will be trained. For each example, that will be compared to those class centroid and create a class affinity graph, and based upon that the similarity of those samples, we will create some attribute vectors like this. So we have some data points. We will create a scaled representations applying some projections, and then we will be having class representations, and we will apply some kind of similarity. We have taken here Hadamard product. So here we have extracted the attribute vectors, and those attribute vectors will be connected to each other to create some kind of micro architecture for teacher also and for student also. And later we will just transfer these these microstructures, we will calculate the losses based upon distances and the angles among these attribute vectors, and transfer this learning to this encoder and back propagate it using a combined loss function. So this is the overall mathematical description. We will be having scale representations, and we will create some CAGs where we will be having some data points as nodes. There will be edges that will be from class centroid to each of the example, and then we will apply Hadamard product to get some attribute vectors, and later we will just apply distance based and angular based structural alignment using different loss functions. You can see here we have applied mean MSE, mean square error, and for angular distance we will be applying cosine similarity, and then we will just apply this final loss function with the KL divergence and weighted cross entropy, because there is a lot of class imbalance, and we will back propagate it using this final objective function. So these are the benchmark data sets. One is about diabetic retinopathy, second is about skin cancer disease, and third is human epithelial cell type 2 data set. These are the evaluation metrics we have used. These are some results which show that we have got around 6 to 7% gain for different performance metrics in case of all the data sets. You can see in case of confusion matrices also, it is able to specify the minority as well as majority class also. This is some result which we have got for class imbalance. So we have applied one constant that is the ratio of majority and minority class. So for majority class, for the severe class imbalance, you can see all the stats we have got is above all other baselines. These are some ablation studies. We have done it in 3 ways. First is about weightage of loss functions. Second is about some loss components. Third is about each of the component, like if we are using that memory, using CAG or not, using some distances or not. We have tested it for different architectures also. Here you can see for each of the architecture, either it is comparable or it is the finest one serving as a baseline. In feature space visualization, you can see we are able to clearly classify in separate clusters. And in GradCam also, you can see that each of the prediction from stock is able to actually choose that pattern where there is a major kind of problem in that image. So it is overall brief generated through AI. So we had some class imbalance, some unique problems also. So ultimately it will lead to some kind of overfitting when we will apply some model. So we have created some CAGs. We have the student and teacher models, and we actually aligned those microarchitectures. Those are actually CAGs, and we have improved around 6 to 7%. So overall, in the conclusion, you can see that our method is able to generalize it better, and the current limitations are actually we have evaluated on high quality reliable data sets. So we have to check it on some low quality data sets also, because in case of medical examinations, there are possibilities that you may have some different kind of scanners which may not be able to give us appropriate results, and then there may be noisy labels also. That area is actually unexplored, and there is we have just tested it for vision problem only. So the future direction will be to extract and transfer more relevant knowledge, and for multimodal learning, then for noisy labels, and then its application for diverse tasks. Okay, so these are the co-authors and my guide. So happy to connect and take questions. Thank you.
interesting work. So the floor is open for questions. Yes.
So in the creation of the class affinity graphs, I did not completely understood how it is done. So you have some embedding vectors for each image. For a certain class, you can do clustering. You know already the clustering, so you create like connect them with edges only, or you do something more fancy.
Okay, a good question. So what happens is that if you have a limited number of examples for some class, so what can you do? You can just make sure that those examples should be aligned with some proper architecture, so that it can be identified that this belongs to this category only. So the method is actually about this only. So what we have done, we have like for majority class we have multiple examples, but minority class there are not that much. So we have extracted feature representations of each class and just took a mean of it. Okay. So those will be our class representations in CAGs. Those are serving as class centroids. Now we are aligning those class centroid to each of the example. That what that will do, that will actually enforce the confidence that this data point particularly belongs to this class according to this model. So that is what I have done here. If you see here, we have class representations, and along with it we have data points. So we are actually taking Hadamard product of these to ensure to increase the confidence of that particular data point to belong to that particular class. In this way it is actually calculated.
Thank you.
Since it's a student-teacher model, how do you make sure the errors are not mitigated to the student model?
It's a teacher-student kind of framework, but in case of medical image, we are not actually considering the teacher model that is separate from student. We are actually taking a student model only. First is that thing. Second is the major problem we have to solve is the overfitting problem. Ultimately, we will lie on that surface only. So what we are doing, we are ensuring that if we are transferring exponential moving average of weights, then the knowledge should be finer enough that can, this teacher model will be just about to like avoid overfitting here. So each time we will just provide the exponential moving average of weights from student to teacher, then the teacher will ensure that the model is not overfitting. Okay, so our framework is just doing the thing like it is just making the fine predictions for student, so that the teacher that will get the knowledge from student here, ultimately that get fine knowledge, ultimately it actually work better in terms of performance or accuracy, you can say. So we are not actually considering teacher student architecture, we are in student architecture kind of. It's just for nomenclature purpose, so that we can differentiate it better.
For class imbalance, you have multiple ways of handling it, right? Like you can handle it either like even very simplistic like resampling or.
Yes, sir.
Did you compare with those, like how that works?
No, sir.
Not exactly.
No, sir. It was around this knowledge distillation work only, knowledge distillation and classification work. So I haven't compared.
The imbalance part. Okay. Thanks.
So let's join in thanking our speaker. Thank you so much. I couldn't get a chance to ask one question.
Okay, ma'am, please.
Sorry, so please coming back. So with respect to your this teacher-student model or your stack pipeline, so you have written that you want to go with the multi-model later on. How much do you think will be it is robust to have your input images where you started with structural alignment over different modes of data sets?
may or may not be robust, that I cannot confidently tell.
Okay.
But everything what we can do is to extract richer embeddings. So we can now there are foundation models and other clip-based models which are already pre-trained. So this study was published in 2024 and actual work was done around 2022 end. So that time those were on just evolution part. So if we just ensure these we are getting data from different modes, we have to just ensure that these embeddings and those embeddings, those should be richer enough for our information purpose. That kind of thing, if it is done, then it will be robust.
Okay. Thank you. Thank you
Thank
so
you.
much. So now please join again for thanking the speaker. Okay, so our next speaker is Shivani Gupta. She is a researcher in the CSE department of IIT Patna and specializing in clinical outcome prediction using multimodal data. And today her talk will focus on predictive modeling for the healthcare outcomes using advanced hierarchical and graph-based AI approaches. Welcome.
Thank you, ma'am, for the introduction. So, good afternoon, everyone. So, today I'm presenting my paper titled with Healing with Hierarchy, that is Hierarchical Attention Empowered Graph Neural Network for Predictive Analysis in Medical Data. So, this is the table of content. We will see each one by one. So, first, what is the clinical decision support? So, when a patient admit in ICU, so in that time, doctor has a very less time to make a decision. So there is a lot of chances that physician may miss a very important aspect of patient health. So this clinical decision support system help physician to make accurate and informed decision without missing any important aspect of patient health. So for this, we use electronic health record system. So it's basically a digital version of patient traditional medical records. So it offers real-time patient-centered information for prediction tasks. So EHR data is basically of three types, that is a structured, unstructured and medical data. So structured is a tabular data, well-structured data. Unstructured data is a free-form clinical notes, that is a textual data. And medical images is a CXR data, MRI data. And these all three data provide a comprehensive view of patient health. So this is an important literature of my work. So in this work, we have used unstructured data. So unstructured data provide a very detailed insight about a patient health. So it contains like symptoms, diagnosis, reason, radiology report, everything it contains. So, but the challenge with this data is there is a lot of missing data, abbreviation they have used, and there is a long textual sequence. So how to get better information from these data? So our objective of this work is mortality prediction, that is a patient will survive during a stay or not, and length of stay prediction, that is how many days a patient will stay in the hospital during a stay, during a hospital admission. So the significance of this prediction is to help identify critical patient who need immediate attention, and next length of stay is it assists doctor to optimize hospital resource management. So this is the methodology. So here this raw text data, every column contains different feature of patient, like present illness, medication, social history, family history, and that red one is a missing data. So first, and every row contains textual data that contain a very long textual sequences. So first what we did, so BERT model can take only 512 tokens. So if there is 1,000 or 2,000 tokens, so many tokens can be missing. So because BERT can take only 512 tokens. So what we did, we divided the long text sequences into small tokens, and then applied the BERT model to get the embeddings, and then after at the end we applied multi-head attention, that are transformers model attention, and get the final embedding. So using this BERT plus MHA, we got the embedding for each features. And for now, the red one is a zero embedding, all the zero embedding. So next we try to fill the missing features. So to fill the missing features, what we did, we applied attention from all the non-missing column to the missing column one by one in the hierarchy. And for that non-missing column, we applied the attention, the next non-missing column one by one, and for using the final embedding, we fill the missing columns. And then did the feature aggregation using the attention mechanism. And at the end, we created the patient graph. Here, node is a patient, and the similarity between two patients is a edge weight. So after this, we applied the GNN to do the prediction task. So this is the attention mechanism of transformers. And this first one is the cosine similarity that we used to create the graph. And this is a weighted cross entropy loss function. So for this, we have used Mimic 3 data set to do the prediction. So it's a ICU based data set recorded from 2001 to 2012 patient. So this is the data set description. So we have two type of prediction. So mortality is a binary prediction, alive and dead, and length of stay is a 4-class classification. So what we did, we taken the 0 class as less than 3 days stay, 1 is a 3 to 7 days stay, class 2 is a 7 to 15, and third is more than 15 days stay. So this is the data set distribution. So for the evaluation matrix, we have used macro F1 score and macro AUROC. So this is the result. So as we can see, our model performed better than all the other baselines. And this is the result with different medical LLMs, language model. So here we got better result for BioBERT, as it is a BERT model trained on the medical data. And next one is using the different GNN model. So we are getting comparable result for GCN and GATO also. So this is the precision and recall curve for mortality prediction, and precision and recall for length of stay prediction. So here our model giving better result from all the other baselines. So our approach utilizes a hierarchical attention mechanism and graph neural network to handle the missing values and long text sequences, enhance feature representation for more accurate prediction, and our model improves the reliability and precision of clinical prediction tasks. So in future work, we can add long-term health prediction using the patient history, means using all the patient visits, we can do the prediction task, apply the explainability in this model, and also use graph-based LLM to do the medical prediction task. So these are some references. Thank you.
We have a lot of time for questions.
So thank you for this talk. I wanted to ask, I did not catch up. How did we go from EHR to a patient graph? So you had per person EHR that you were processing with BERT. So how did you reduce it to a patient graph?
So every node is a patient, and each patient has an embedding. That embedding we got after the feature aggregation. Every patient has an embedding. So using the cosine similarity between the embeddings, we created the edge, and patient is a node.
Okay, and one more. So you used a BERT model, which is an encoder model. So why not use a generative models like GPT-2 or other ones?
So we can use that. Actually, next work we are doing using the LLM only. For this, I have used only BERT model and different BioBERT, because it has also the less parameters. LLM has lots of parameters. So that's Thank you.
Hello, Shivani. So nice talk. I just want to ask, this is in Mimic 3 data set, which is going to be there. So one is how different it is going to be the Mimic 4, the 5, which is recent.
Actually, I have also tested it on Mimic 4, but the result is not here. So Mimic 3 and Mimic 4 is basically almost same.
They made some changes in that EHR reporting in a sense, and for the embeddings part. And the other was let's say if we want to work in a more Indian context, like the ABHA and those kind of Ayush IDs which is provided, so they also have these kind of embeddings there. So have you ever tried thinking about in more Indian context for these?
Indian context means English text only.
Yeah, the structured. Yeah.
So actually the medical text, medical data problem, there is not very much available medical data. So Mimic 4 is a well-established baseline.
For the ICUs and all.
Yes.
So currently India is also going with these, EHR data where several of them has now adopted the ABHA part. There are certain differences from Mimic and all. So that, I mean, it looks like that it will be a very good opportunity to work on an Indian context with this.
Yes, ma'am. We are trying to actually collect the medical. We are working on collecting the medical data set in Indian context, and then we apply.
And you are based in Patna.
Yes. Right.
So Patna has several hospitals who are actually have adopted this.
Yes, ma'am. We are collaborating with many hospitals also.
Yeah. Thank you.
Thank you, ma'am.
Great. Any more questions? Question from that side. This is like class mode on, like no questions coming from that side. Sorry? Stand there.
I have a pretty basic question. I just want to understand how the dual prediction is being made, because like you are predicting both mortality and duration of stay. So like with respect to mortality, you would have alive or dead, and then stay as well.
Actually, it's we are one by one we are training the model and then applied on the test data.
So it's predicting them separately. The model is running twice for each.
Yes.
Okay.
Yes. Thank you.
So what kind of GNS did you use in your for node classification finally?
It's GCN and GAT.
GCN and?
GAT.
GAT. What about others like GIN or GraphSage?
No, I have not tested on that. I have used only these two.
Okay. Generally, GIN is supposed to do better than
Which one?
GIN, graph isomorphism networks.
Oh, sorry, I have not used it.
Maybe that would perform even better. That's one avenue to look at. And can you once again explain how you got those missing values? I didn't get that part.
So this red one is a missing value.
Yeah.
So in the starting, what we take, take the mean of all the embeddings, and then from the non-missing columns, we applied attention one by one from the missing column and update the context vector every time. And at the last embedding, we fill the missing columns using the last context vector.
Thank you.
Thank you.
Okay, we might have one last question. Anyone? We have time for one last question, but if no one has it.
So very, very basic question. So in the data set that's created, so you're also predicting the number of days that the person will stay in the hospital, I suppose. How is that data generated? Because mortality, I can understand there's a finality about it, and so there is no, but how do you generate this data in terms of, because when does the person, there's no specific condition under which the person would leave the hospital. It could be financial, it could be personal, it could be anything. So what is the correlation between the input condition and the number of days that the data, even for the data set? Is there any explanation for it that, predict, because there could be many other parameters that may be important other than the medical condition.
Sir,
the number of days in the hospital.
So sir, we have used Mimic 3 data set. That is a publicly available, well-established data set.
But that's fine. Yeah, I can understand. So your job is only to improve that, but do we have an understanding of, even if I'm predicting something, there has to be some meaningful correlation between, because Monica asked about, Indian data set. So now how do I, because people leave the hospital for, there's no very specific condition that under which the people leave the hospital.
Yes, sir. So
it is. Agreed.
Sir, actually, in textual data, there may be symptoms like fever or small disease, something, very simple symptoms or something. So for that condition, length of stay will be very less. maybe model learning for that. For severe disease like cancer or some other disease, maybe length of stay will be very high. So that model can learn.
Well, you can continue the discussion later. Yeah. So thanks. Let's thank the
Thank
speaker
you,
once again
everyone.
for an engaging Q&A session and a talk. So our final speaker for this session is Subhashri Kumar, who is currently pursuing her PhD in Computer Science and Engineering in NIT Calicut. And today her talk will explore the integration of cognitive science, insights, and AI techniques for predicting and detecting learning disabilities in healthcare and educational systems. Oh, okay, cool. Yeah. Please welcome Subha to the stage.
Good afternoon, everyone. My name is Shubha. I'm guided by Dr. Ligia as an associate professor at NIT Calicut. And also the co-author of this paper is Rajat K. Ravindran, who is a psychiatrist at IMHANS, Calicut. So IMHANS is Institute of Mental Health and Neuroscience. This is a review paper wherein we are connecting the cognitive science perspective and the AI perspective on learning disabilities. So if you look into the nature of the two areas, they are totally different. One is cognitive science, wherein the work is around 100 years, and AI has just catched up with it recently. So this is a review paper which is connecting both this. So coming to the introduction, this says about specific learning disabilities. They are neurodevelopmental disabilities specifically affecting the academic skills like reading, writing, and mathematics areas. So individuals with SLD, they have above average intelligence. So that makes a difficult opinion here. Like if you find a child who's with difficulty in reading, but he is very good at all other aspects, we'll only question him that he's not reading. So that's an issue here. So the issue is for lifetime, and it's very late, they identify it, and then by then the child would have lost, its interest in learning, or he himself doesn't understand what his condition is. So the stats says that 5 to 15% of the global population is affected by SLD. And the major SLD are dyslexia, dysgraphia, and dyscalculia, where dyslexia is issue with reading, dysgraphia writing, and dyscalculia is mathematical concepts. So they hinder their academic progress, which also reduces their low esteems and self-esteems, low self-esteems. And then this also leads to less long-term success. And SLDs cannot be cured, but they can only be managed by support. So the motivation for my work is there is very limited awareness of SLD among parents and teachers. So I met a parent who brings her child to the institute for training. So I asked, how did you identify? Was it from the teachers? So she said, no, I have a 4-year-old child and a 4th class child. So when I teach the 4th class child, the 4-year responds better. So then she identifies that there is some issue with the child and then takes. So earlier it was by the teachers. So they identify such issues and then they refer them to psychologists, and then they do a lot of tests and then identify such kids. So there is limited awareness of SLDs among parents and teachers, and early detection is essential for early intervention programs. So if the child knows that this is a disability that he is, and if he comes in terms, his parents and he comes in terms with it, then he might from the start identify other areas wherein he can thrive. So schools are the key important referrals where these assessments are referred to. And nowadays, they lack standardized screening and referral tools. So disability selectively impacts, that's what I said, it selectively impacts the academic skills. So it's very difficult to identify them. And sometimes they go unidentified also. SLDs received official disability recognition in India recently in 2016. So that's very recently. Then there are, by the government side, we have composite regional centers, that is around 25 overall India. And then we have BRCs, which is block resource centers. These block resource centers, they go to the local schools, identify how many students are there who are affected by this, and they prepare the curriculum for them. And then they also give classes. But the classes are like, if you have classes from 1 to 10, for 1 hour per week, they might give some class. So that class doesn't take care of the need of the child. And the CRCs are doing good job. They conduct one-to-one class. But then the children who comes there are not just with SLDs. There will be intellectually disabled children, children with ADHD, and children with all other issues. So as SLD assessment in India is done by psychoeducational assessment by a clinical psychologist. So it includes IQ testing, academic achievement tests, cognitive processing tests, behavioral observations, and interviews. Okay. So this NIMHANS SLD battery is a mostly used battery that is used by the psychologist to test them. So what the catch here is psychoeducational assessment. So they are checking the educational assessment, which can be in a way automated by AI. Then diagnosis, rules of intellectual disability, lack of instructions, and sensory deficits. So based on the assessment and based on the results they get, some amount over a period, maybe 6 months, 1 year, they give a intervention program, and then they take the test read. They retake the test. So how is cognitive and AI connected? So the assessments are, they are testing the cognitive skills of the child. So if it's dyslexia, they'll check the phonological processing, the reading accuracy of the fluency, then the spelling, then automatic memory, randomized automatic memory, then working memory, processing speed, all those. And dysgraphia, also they check the handwriting, because it is written, it is based on the handwriting. They check the handwriting, the motor skills, letter formations, etc., spelling. And then dyscalculia checks with the mathematics side of it. So now AI can enable, help with identification of these, so that the psychologist, the other side, can improve the look into their behavioral or such issues, like if they have low esteem, how to improve that. Those things can be checked by the psychologist if we can automate the other parts of these kinds. So this is the review that what we have seen. Like we took a lot of works from both the sides, AI and cognitive side, and then we drew the network of bibliography, and we found that the work is also in the cognitive side itself. The work is spanned into different dimensions. That is because as such there is no metric which identifies this is it. So they are also looking into various dimensions of the disability. And then what AI can do is help these people with these other dimensions and analyze how it is. Maybe we can, with the help of AI, find better biomarkers in identifying these disabilities. So these are the ways in which I have wrapped up the review. Like we have looked into psycholinguistic and neurological studies, where psycholinguistic studies looks into the phonological awareness skills, spelling skills, and those kinds of studies, and neurological studies, which is looking into the functioning of the brain. And then these were the things that we could relate it together. So EEG, MRI, MEG scans, and all these can also be automated these days and interpreted by AI models. So SLD involved abnormal brain processing at the visual, auditory, phonological, and sensory levels. Okay. Then visual processing weakness were identified from the eye movements, poor symbol recognition, reduced reading efficiency and fluency accuracies. Then motor movements and handwriting, the spelling issues, Then phonological speech sound, that is, phonological is mainly the speech and the sound. That is, the child has to identify A and it is related to the sound A. So that issues. Then SLD reflexive, not just these, that is the vision, all other sensory parts are being affected. So the works are also on the proprioceptive deficits and also on the brain rhythms. That is, they also play, they've also tested on music also, how the child responds. So the broader idea is that it affects all the sensory parts of the body, but the work is concentrated to visual, then hearing, and then writing parts. So we identified the modalities. Main works are on the modalities like eye tracking, handwriting analysis, speech analysis, game-based assessments, and signal processing. And we have also mentioned the cognitive parts that is being tested by them. Okay. So the scope is that since India has identified it very recently, many works have to be done, and there are many children who've been left helpless. They bring the child, then for 1 hour they bring from, the centers are only 25. So even they travel by train for the single day, come here. Then for 1 hour, you will not have a single person attending to that unique child. There will be 5 of them sitting and then saying this. So there is a lot of scope that we can ease their efforts, such as low-cost AI-based screening tools can be developed, strategies like large-scale privacy-preserving standardized assessments can be made use by the AI models. And then multimodal nature, that is because you look into one concept, like either the handwriting will not do. You have to look into all the other aspects. So that itself is tiring actually for one psychologist sitting doing all this. So if some part of it can be automated, that's good. Then the main part is in the assistive technologies, like you have the Shiksha classes. Similarly, if you have something wherein you can assess them over and over again, because it's not like you tell them once and they learn. So you have to teach them multiple times and you have to mark the improvement. So that is also a major. So my part is, I have just looked into the screening it in the school level. So early you screen it, you can refer them to the nearest psychologist. So I've looked into the handwriting part of it. So where handwriting can be looked into both dyslexia and dysgraphia. The spelling issues exist both in dyslexia and dysgraphia. So this is one sample, how the children writes. The spellings will be not normal. And then reversals, all these are the samples. So why handwriting? That is because we can easily collect it from schools, and teachers are also prone to looking into them and identifying the issues. Then it is cost effective, teacher friendly, and also good for early detection. Okay, this is just a sample that we are working on. So you can identify the difference in them. So both of them are from a 3rd standard grade. And the person with SLD couldn't complete those 15 words. And these are the works that is published in this area. And a few more are to come. And the data set is also about to be published.
So how large is this data set, the work that you are working?
That's an issue here because only 5 to 10% of the worldwide population has it, and most of them will be gone unnoticed or they don't identify it in the early stages. So I have connected with IMHANS, so they test the children there. SLD data cases that we have got is around 30, but in among the 30, we don't have, there are also children who don't even write. So the child is in the 4th or 5th standard, but may not write even fan. So there are issues of that kind. You know, you don't have the bigger data set. We have a smaller data set wherein we have tried to extract the features and then use simple machine learning models too.
This is because like we know that for AI to help, we need
a larger data.
Larger data. Even in medical domains where like our previous presenters have presented, like they have shown that like there, even if there are like very few positive, true positives are identified in the data set, then also like there are intervention that could help. So why we can't have it like, for example, for the entire school or something?
I've collected both the data. From the schools I have collected, and then we want authentic SLD students data. So that we have collected from IMHANS. And the school data are additional, but the thing is that we have to catch the target group, which is SLD. So that we have got very few. So what we plan is to have this rolled out as a tool and then use it in the schools. So then from there, we might get few more samples which have to be tested by the psychologist and then put in.
Anyway, I think partially the question is answered. So the idea is that if it's a screening test, won't it be better that just have arrangement with a large number of schools in a city?
Yes.
And typically start collecting the data.
We have done with the small amount. We have generated a model, not just a model. It's like an ensemble model, and then the tool will be ready shortly. And then we are planning to put it nearby schools and then look out what the result is.
So my question is that this, you said that some students will not be able to write, let's say in English.
Yes.
Would it be possible to, let's say, write in Malayalam or Kannada?
What the parents does is when they identify the child has got some issue like this, they'll just change the standard medium. Like if he was studying in English medium, they would change him to the state level so that he needs to look only his regional language. So the initial idea, what we have done is whether this is possible or not was our testing. Okay, with the dictation test, can we screen people? So if it is possible, then we'll be morally interested into regional languages like Malayalam, because that will be more like in schools, school level. If you look into most of the schools in Kerala might be in the state level run schools will be in the Malayalam medium, and it is a good idea that he need not learn the English in add-on to some other language. So it is like reducing his baggage.
No, what I meant to ask was that, does dyslexia actually, does it come for all languages or
yes,
is it?
Yes.
So even then there'll be pattern changes in the.
Yes, it will be there.
Okay.
So region-wise testing and research on it is necessary actually. Now IMHANS, they are also giving out tests on different regional languages. So the word sets they give that have to be tested. Actually, according to the 2016 Act, what it says is by the 3rd standard or mandatorily we have to test the kids for such disabilities. But that mandatory, how is it done is a difficult question because only the teacher identifies the child. So if it was earlier on where the child goes to the government school, he'll be there the teacher might even know his parents would have been studied there. So there is a clear idea of the child there. But now in these, where you have the private universities, schools, where, the teacher comes and goes every year, that connection is lost somewhere. And then the teacher fails to identify the child with the issue.
So I have one more question. Is there anything for dyslexia and dysgraphia, that there's some issues with the handwriting. Is there something for dyscalculia as well?
Dyscalculia is actually when you see the very less number of children will have dyscalculia when you compare it to dyslexia and dyscalculia. So dyslexia and dyscalculia, you get the data set somehow. Okay, but dyscalculia, very, very few persons have it. So it was very difficult. I've just found one. All
Okay.
these years, just found one. And that she is in 9th standard. I tried asking her to write. I just asked her write in English. She wrote it. And then I understood she's not got a issue there. Then I thought, okay, then we'll try with Max. Then she understood I'm judging her. She told me, why do you ask me all this? So at that age, it is very difficult. They think that we are judging them. So it is better to catch at the earliest and make them understand this is a lifelong issue that you have to deal with.
Yeah. Thank you very much.
Thanks for the presentation. My question is not directly related with what you have presented. Can we do similar kind of studies for the ADHD sort of activities?
Yeah, there are works. I think ADHD and all, many EEG related works are there these days.
Because maybe some kids, they are like good at learning or may not be good at learning irrespective of that, but they may be very good in different sort of activities like sports or other stuff.
ADHD is a highly looked into topic these days, I think, EEG based.
So
then there are some wearables measuring their activities and all.
So there are data sets for that also?
Data sets, I don't know. I've not looked into
Well,
it.
my kid seems to be hyperactive. So I want to understand from that point of view.
These days, I think most of the kids are hyper.
Okay. Thank you.
Maybe the last one. It's rather than a question, it's a comment on it. Dyslexia actually is a correlation between writing and speaking.
Yes,
You're only using one part of it.
Yes.
What are the peculiar features which will distinguish a otherwise non-performing student than a dyslexic student?
Yes. When we went with the handwriting, that was the first question. So we thought of giving a dictation test and identifying. So the question was like, what if the child has not learnt it? So that's an issue. But then what?
Why don't you do correlation between speaking and
Yes.
writing?
So initially what we have taken as the dictation task, and then we found the issue is with their phonological idea. Like if the child has got that phonology with him, and you ask them to write the dictation, he might, with the sounds, he might write it properly. With the sounds, fan, the sound he would have got it if it is not a dyslexic child. So he'll try to write it as fan itself. So the word. It's only handwriting. I could only do this much this years.
So basically, you said you're still looking at coming up with screening tests, right?
Yes.
But there are already screening tests should be standard, right? There should be a set of screening tests.
But they're not being used. They don't
But
there is one.
How do doctors classify a child,
that's
or how
not
do they?
Screening test. They have it's an enhanced battery. That's like you get a report kind of thing.
But no one does screening tests before
Nothing,
going there.
no.
Oh, okay.
So it is referred by the parent or the teacher, like how I said about the 4th standard and the 4th year child.
Oh.
So they find the difficulty and then they go to the psychologist.
Thank you. That's great.
I just have one thing with respect to all these cognitive skills, the ways that it is, how do you think an AI will be able to handle the bias which actually comes with, I think, all the cognitive things? For example, let's say when you talk about dyslexia, so you have so many questions where they say that maybe the student has not learned it, the student is not able to do it, or non-performing student. So the identification of the result will come with respect to which we think is a part of a dyslexia.
Yes.
But may or may not be. It may
That's
be
the reason
the kind of growth spurt the child is having. Some may be able to learn at 3 years, some may be learning at 5 years. So if the child is kind of tagged at 3 years as a dyslexia, then how do you think these kinds of biases can actually help that?
Actually, our works is on 3rd standard to 5th standard. So there are works which says that even before the child learns, you can identify it by their some graphical drawings and all those things, their hand movements and all.
Yes.
But then our work is basically from 8 to 10 years. By the 8th year, the child should have learned to write. The letter reversals and all those things would have been over by then. So 8 years to 10 years is a better age to identify.
Okay.
So question is not appropriate, but I wanted to ask, instead of handwriting, why is it not possible to utilize drawing or graphs to identify dyslexia? Because, for example, I have a few friends who have dyslexia. I have 4 or 5 friends, and what we noticed was their movements while drawing and while making graphs is much more different. It takes them much longer, and also the lines are not appropriate. So is it not possible to, instead of use handwriting, use drawings and graphs to analyze and identify dyslexia, because that would also overcome the language limitation which we had addressed if the student does not know that specific language?
Oh, I've not thought of that way. There are works I told, like even before learning ABCDs, you can identify, but then I've not thought on those ways.
Very nice question.
So for handwriting, till now, have you figured out any patterns or features that do exist? Like in terms of, is it like the way they jumble up the letters in words, or the specific way in which they write? Has there any identification like been done regarding
Actually,
that?
this issue has got there is people with very less severity, and there is people with more severity. That is not even Indian standard. If you have 40% severe, then you are eligible for the disabilities. There are other compensations for it. So that severity is not at all measured. Actually, it varies. It really varies. The people with less severe, they are more like us. I mean, they're like us in the sense their writings are more like us. And very severe people, they'll not lift their pens to attempt it.
So then,
So we just give them, see, fan, what is the sound of the first, but then they just ignore it.
see, but then AI would only be able to detect like moderately severe to highly
yes,
severe things, and then people with less severe dyslexia would go unnoticed.
Yes,
And then that would be an issue regarding that.
But then this is our duty is only to screen it. You cannot tag someone and say you have such an issue. So we'll only screen it at the school level. So you screening us by by looking into their handwriting learning skills. So we can only do at that level. So people with more severity, we've just left it as such in the
Thank you.
I just want to make one comment. The amount of interactions that is happening shows that reviewers did a great job at selecting papers. Yeah. Yeah.
Especially this talk spiked so many conversation and interest. Yeah. Thank you. I would like to thank all the speakers who have been there in this engaging session after lunch. And I would like to invite all of them on the stage. Please join me in inviting them. Please. What? Okay.
You want this? I think we need
I would request the session chairs to please present the mementos to the presenters one by one. I would request all of you to also come to the stage, please. We'll take a group photograph and also present this memento. These are ones that have been specially designed in the maker space at Plaksha. First, it would be for Mr. Azad Singh. Next, we have for Dr. Saurabh Sharma. Now we have Shivani Gupta. And lastly, Shubha Sri Kumar. Got it. Thank you so much. Yes. Thank you so much to both the session chairs for conducting the entire discussion. I would request everybody to now proceed towards the auditorium. We'll be having a session by Dr. Renu Rameshan. And also for all the students for the Emerging Trends in AI and World of AI course, please mark your QR code.
This will start at 4:45 p.m. Students in the Emerging Trends in World of AI course, this is the been having a good day here. It's my pleasure to open this session on robustness in computer vision, spanning 4 exciting presentations. Our chairs for this session are Dr. Anupam Sopti and Dr. Deepan Muthirayan. Dr. Anupam Sopti is an assistant professor at Plaksha University and leads the Geospatial Computer Vision group as well. After completing his PhD from IIT Delhi, Dr. Sopti worked as a postdoctorate researcher at Microsoft Research India. His current work focuses on applications of ML and embedded systems to reduce the information gap among various stakeholders in different industries like agriculture and healthcare. Dr. Deepan Muthirayan is an assistant professor at Plaksha University. He obtained his PhD from the University of California at Berkeley and was a postdoctoral associate at the ECE department at Cornell. His current research focuses on the applications of reinforcement learning and ML in robotics and multi-agent systems. He is also working on exploiting foundational models in robotics to make these systems ready for physical world utilities. With that, I would now like to invite our session chairs to begin the session.
Thank you, Shivangi. Welcome, everybody. So this session focuses on advances in computer vision with an emphasis on robustness and reliability in challenging real-world conditions. From satellite imagery and adversarial resilience to domain adaptation and image enhancement, the talks highlight innovative approaches to improving the accuracy, generalizability, and trustworthiness of vision systems. These contributions reflect the growing importance of developing AI methods that remain effective across diverse environments and adversarial scenarios, ensuring dependable performance in critical applications. So our first speaker, Rishabh Mondal, is a PhD scholar at the Sustainability Lab, IIT Gandhinagar, supervised by Professor Nipun Batra. His research lies at the intersection of Earth observation and computer vision, focusing on environmental monitoring, geographical domain generalization, and foundation models for remote sensing. Today, his talk will explore methods for detecting and analyzing environmental structures using satellite imagery with robustness and accuracy. Please join me in welcoming Rishabh to the stage.
Thank you, Professor Nipam. So I'm talking about our research paper. Is it playing? I think. So I'm presenting my research paper Sentinel CleanDB, which is accepted in URIPS 2025 in dataset and benchmark track. So air pollution is responsible for almost 2.6 million of deaths in South Asia, where India alone 2.22% fatalities in India alone. So amongst different air pollution contributors source, so today I'm talking about brick kilns, which is almost 8 to 14% of air pollution in India. Growing urbanization also essential need of brick kilns is there. It also provides 15 million people's daily livelihood. So we can't stop them. It's something we can change. So there are different technologies of brick kilns. The older technology is circular and fixed chimney kilns, and the newer technology is zigzag, what is 40% fuel efficient and pollution efficient than older technologies. Government of India also set some compliance rule for brick kilns. All the newer brick kilns should be permitted as a zigzag kilns, and older technology should be converted as a zigzag. And distance based also some compliance is there. First is from human habitats, it should be minimum 0.8 kilometer, and between two brick kiln distance is 1 kilometer minimum. So what is the problem? Problem is till now the traditional method of geolocating the brick kilns is using what is using by the air quality expert is Google Earth Pro, and geolocate the brick kilns in 10,000 kilometer square area almost takes 12 hours. And second thing, if we did it through the ground based survey, it's also take lots of time and cost as well. So we need one scalable, automated, reproducible, large scale framework to monitor this unorganized sector. So objective is basically first geolocating the brick kilns automatically, and then compliance monitoring from that location, and then classification of older technology and newer technology. So our end-to-end ML pipeline is first detect the kilns with its accurate class, then automatic compliance monitoring, then air pollution simulation, then the evolution over the time, is the technology is adapted or not. So here we present our dataset, Sentinel CleanDB dataset. This is the biggest ever dataset on brick kilns till now. Before that, there is another dataset is there, which is from Stanford, Stephanos dataset. To build up the dataset, we are using basically 4 types of satellite imagery. What is Sentinel-2, 10 meter per pixel resolution, Planet 3 to 5 meter per pixel resolution. Okay, is it fine? Okay, so mainly for model training and prediction, and S3 for hand validation, and ESA land cover map, which is for the negative sampling. We focus on the oriented object bounding box based object detection because of accurate area estimation. For downstreaming tasks, accurate area estimation is necessary, because if we calculate the area of a brick kiln, then we can calculate the product of how much brick is production for a brick kilns. So if production is calculated, then pollution can be also estimated. So we go for the OBB setup. For initial dataset curation, we take 4 regions: Delhi airshed, Lucknow airshed, and West Bengal. And we also build up on user developed platform with no download setup using S3 map imagery. And we curate 41,000 Sentinel-2 tiles with ESA world cover map with high class confidence, 99.9%, for reducing the false positive rate, for learn the model where not to predict the brick kilns. This is the pipeline for build the Sentinel CleanDB dataset. First, we labeling and train YOLO or any kind of object detection model, but it should be OBB setup. Then we predict on 2.8 million kilometer square, I mean Afghanistan, Pakistan, India and Bangladesh, and then predict on Planet Labs imagery and hand validate the prediction with 50% confidence threshold with SRIM imagery, and we round 3 times that process and extended our dataset to 63,000. Then we transfer the label to Sentinel imagery and published the data. We need Sentinel-2 imagery because for Planet and S3, both of these satellite product, we can't publish the raw data due to the publication issue or licensing issue. So overall data set, Bricklin distribution, we cover almost 4 Afghanistan, Pakistan, 10 states of India and Bangladesh, and this is the state-wise distribution of Bricklins. We can see that Pakistan, Punjab and Uttar Pradesh is the mostly Bricklins are there, and class-wise also UP is still now, there are older technology, most older technology CFCBK is still present there, and also FCBK and zigzag is 50% of distribution is there. So in India is 42%, 42,000 almost Bricklins is there, where the 50-50 is older and newer technology. But in case of Bangladesh, for government push up on Bricklins, almost Bricklins are converted to the newer technologies. But the Pakistan and Afghanistan both are the same using the older technologies. So overall statistics is this, the older and newer is almost still now lead by the older technologies, and zigzag is the 42%, but CFCBK is almost discarded. And then we set our data set is almost roughly 70-30 setup. Okay, so to check the robustness of our detection, we did also the district-wise manual verification data of Uttar Pradesh data 2023 survey and compare our hand validated Sentinel CleanDB data, and we find that 96% correlation coefficient between the two data. For compliance base, distance-based compliance base, almost 70% of cleans are non-compliant according to the Central Pollution Control Board, and 30% are cleans are only compliant. Every state pollution control board also set some rule for their Bricklins, and we can see that West Bengal only 25% cleans are only compliant, and Bihar 24%, where the Uttar Pradesh 15%, and Haryana is 40%, and Punjab is 55%. And we developed one automatic compliance monitoring app for the policymakers where they can easily find the Bricklins and let learn and which compliance rule they break. Also note if you point that we mouse point that cleans. Okay. So on technology based compliance monitoring, we see that when the Central Pollution Control Boards put the record on 2017 passed their bill. After that, in Delhi, most of the Bricklins are converted, drastically conversion of older to newer technologies. But at the same time, Lucknow, the growth is almost similar. There are no change in older and newer technologies. Now we go to the Sentinel CleanDB benchmarking part. Firstly, we set the in-region detection. We test 28 state-of-the-art object detection model, including 2 state, 1 state DETR-based and remote sensing foundational model. So this table is used, so we can conclude that table. So we can see that recent model Terramind and Galileo, which is the recent ICML 2025 and Terramind also ICCB 2025, both are foundational based model and both are outperforming traditional model like YOLO and RTDETR. Then we go to the out of region generalization setting. We train one model on Uttar Pradesh and test on unseen region like Pak Punjab and Bangladesh. We see that there are, as per expectation, there are performance decrement when the region is shipped. As well as temporal generalization case, our dataset is completely built on the winter data because winter is the most active state for bricklines. But for year-round monitoring, any model when we test on different region, different season, then the model performance also decreases. On T4 setting, low resolution images is discarded the fine details from an image. So fine details from an image. So we super resolve the images and test how the model performance is there any boost or not. So we can see that there are almost 25% of model performance boost when we super resolve the images. So impact on point of view computer science. So after 2017-18, we can see that there are drastic growth on the oriented object detection model methodology. But most of the model are evaluated on DOTA and diode dataset. So both are high resolution images and also urban centric images. So accurately evaluation, we need one low resolution robust dataset with domain shift setup. So here we present our first largest low resolution OBB based public dataset. So this is the overall key contribution, and so this is the first OBB based low resolution dataset, enables accurate field level emission for air quality modeling like simulator or emulator both settings, and also policymakers can also help from the dataset. And for CS communities, this can be a very good test bed for cross region model robustness as well as transferability. Thank you. Any question?
Thank you, Rishabh, for that very interesting and socially relevant talk. Okay. Thank you. Our next talk is by Vishesh Kumar. He's a PhD scholar in the Department of Data Science and Engineering at IIT Bhopal, supported by the Literature of Services. This research focuses on trustworthy and scalable AI, adversarial robustness, and computer vision. Today, this talk will cover the strategies for building resilient and scalable computer vision systems that can withstand adversarial challenges. Please welcome Vishesh Kumar to the seminar.
Hello. Even governments are also spending lots of money to make the AI more secure and trustworthy. For example, in 2024, under the India AI mission, Indian government allocated more than 10,000 crore rupees to develop the Indian indigenous AI technology and make it more secure and trustworthiness. Apart from the central government, some state governments are also integrating this AI technology in various sectors like healthcare, education, agriculture. So the biggest question is that are these AI models secure? Because most of the AI system integrates deep neural network. And over the year of studies, it has been shown that these deep are highly vulnerable to adversarial patch attack or common corruptions, common image corruptions. For example, here you can see that in figure 2, over the year of literature published that showing the vulnerability of deep neural network against the physical adversarial patch attack. Similarly, in figure 3, over the year literature published, which shows the vulnerability of deep neural network against common image corruptions. So let's understand the vulnerabilities of this deep neural network by this visual abstract. So suppose there is a autonomous vehicle moving on the road, and there is a stop traffic sign. So if this stop traffic sign is clean, means it's not manipulated, the deep neural network integrated in this autonomous vehicle correctly identify it and pass the instruction to the controller that, hey, there is a stop sign, please stop the vehicle. And the controller will stop the vehicle completely. But when an attacker comes and they just paste a small adversarial patch to that stop sign, the deep neural network integrated in this autonomous vehicle confused. And it's misclassified this stop sign as a speed limit sign. And it's passed the instruction to the controller that there is maintain the speed of 40 km per hour. And that can, since it's not obeying the traffic rule, so that can be an accident or collision. So you can see that how this kind of small adversarial patch can be dangerous for this autonomous vehicle or for any AI technologies. So these are the possible threats that can use to degrade the performance of the deep neural network. So first one is the natural corruption. Natural corruption is like an unintentional kind of attack. It exists in the real world. And second one is the adversarial attack. Adversarial attack basically a handcrafted input by an attacker that can be used to mislead the decision of the deep neural network. This adversarial attack can be of two kinds. First one is the adversarial patch attack, and the second form is the adversarial perturbation. In this work, we have combined this natural corruption and adversarial patch attack. So these are the 15 different types of common corruption that exist in this real world. Our main focus is in one of the category of this natural corruption, which is noise. And there are 3 different kinds of noise in common image corruption. First one is the Gaussian noise. Gaussian noise occurs due to low lighting condition. And the short noise occurs due to the discrete nature of light. As we all know that the light is not a continuous wave, it's a small pocket of energy, like a photon. And the third one is the impulse noise, like it's caused by a bit error. Like due to when we are transmitting the data, when we are storing the data, then this impulse noise will occur. So in our research, we have taken these 3 different kinds of common image corruptions, and here we have adopted these 10 different kinds of adversaries which represent 10 different class of ImageNet dataset. So here we can you can see that we have applied these adversarial patches and these common image corruptions on the ImageNet 100 validation set. And you can see the vulnerability of this deep neural network. The first column represents the deep neural network we have used in our research, and the second column represents when the images are clean, means the actual performance of this deep neural network on the ImageNet validation set, ImageNet 100 validation set. And the third column represents when we have applied only patch to the images. And the fourth column represent when we are applying the patch along with the natural noises. And you can see that how this multiple singularity can degrade the performance of these deep neural networks. So means this multiple singularity degraded the performance of this deep neural network. So we have to develop a good defense to tackle with this kind of problem. So this is the two different way to create the defense. So the first one is like global level. Like on the image level, we are just detecting that either this image is manipulated by any adversarial patch attack or this image is real, like a binary class classification problem. Okay? And the second one is patch detection, where we are localizing the patch, like if this image is attacked by any adversarial patch or if this image is manipulated, then exactly where this patch has been added to this image. So in our problem setting, we are dealing with global level classification. So these are some literature survey we did based on our problem statement, and we have identified this gap. Like the existing literature are less robust, means they are not dealing with this multiple singularity. Like they have not studied the impact of this multiple singularity on the vulnerability of the deep neural network. And the second one is they are less generalized, means they if during the testing, if there is unseen patch comes under attack, they are not more robust to detect it. And the third one is the explainability. Explainability is the main contribution of our paper. So I will explain it later. Like in traditional method like GradCam, TSNE, the people are introducing or we are introducing like the post hoc explainability. First we are designing our model, evaluating it, and then we are finding GradCam or TSNE, like where exactly our model is focusing, how they are doing the taking the decision. But in our model, we have applied the in hoc explainability. Means during the training, we have included the explainability. So the identifying this three gap, there is two need. First one is we have to develop a large scale benchmark data set which combine this both multiple singularity. And the second one is we have to find a unified solution which satisfy these three gaps, like robustness, generalizability, and explainability. So for the first gap, here we have created a large scale data set. We have taken 4,000 images from the COCO validation set and 4,000 images from the ImageNet validation set. And we have developed a data set which containing 40,000 images which contain 10 different kinds of adversarial patches and 2,000 images as a clean and 48,000 images which consist multiple singularity, means 48,000 images contain adversarial patches along with these three kinds of common image corruptions. Our goal is to like only responsible data set makes the responsible AI. Okay, so as I told that the explainability is the main part of our main contribution of this paper. So suppose there is a two-class classification problem. First class is real image and second class is patched image. And I am telling you as a human that please classify these images to their correct corresponding class. Okay, so when you are looking for the patched image, there are patched image and real image. There is two different prototypes forming in your mind. Like when you are looking for the patched class, you are just looking for the patch. You are not care about the real part. Where is the real part or not? We are just looking for the patch. And for the real image, you are not looking for the patch. You are just care about the real part. Okay? So means there are two different prototypes forming in your mind. But what the existing model does, they give the combined prototype where the adversarial patch and the real part are combined, means texture of the adversarial patch align with the texture of the real part. So that leads to a false detection, right? But we have designed our model which give us two separate prototypes for two different classes. Like if it's give a prototype for the patch class, there is only the prototype, patch prototype presents. And for the real class, there is not any part of this patches present in the real class prototype, as you can see in this figure. Okay, so let's come to the model part, like how we have designed our model by motivating the human perception. So in first part, what we have done, we are doing the two-stage data augmentation technique. In first stage, we have applied the location-related augmentation, like translation, scaling, and rotation, which exactly occurs in this real world. And it's also degrade the performance of the deep neural network. And in the second stage, we have created two different views of the this one image. Since human will still consider two different views of the same image as the same, but the deep neural network will give two different feature representation of the two different views of the same image, right? So what we have to done with human perception, somewhere we have to align this feature representation given by this model and teach the model that two different representation of the same image will be the same. So for doing this, aligning on the image level, what we are doing, here we are aligning on the patch level. So what we are doing, for the ResNet 50, I am just giving one of the example. Suppose we have taken ResNet 50 as a backbone. So from the second last classification layer, we have removed the classification layer and the second last layer, we have just changed the stride from 2 to 1. So we get the feature representation 28 into 28, 2048. Means we are getting 2048 feature maps of dimension 28 into 28. Okay? So here we are, for this two representation, here we are getting two different kinds of feature map of dimension S cross W cross D. Okay? And here we have proposed a loss function, which is patch decorrelation loss. So what we are doing for this two feature representation, we are calculating cross correlation matrix, and we are mapping this cross correlation matrix with the identity matrix. Means we are aligning each patch of this feature map of two different view, so that the model will learn that these two feature map are same, they are not different, inspiring by the human vision. And in second thing, since I have told you that we are looking for the prototype for each class. So what in the second step, what we are doing, on the same feature representation, we are applying the softmax over this D patches, so that for each location of the patches, we will activate at least one prototype from each feature map. Okay? Or here again, to align this softmax representation of these two feature vector, here we have for introducing the alignment loss. And then what we are doing, we are applying max pooling of each feature map, so that from each feature map, at least we get one patch. And then we are getting here is a prototype vector, which represent basically a one image patch. And since from each mini batch, we want to get diverse types of prototype. So here we have applied the 10H loss, so that for each mini batch, there is no only one prototype will activate from the one prototype. Okay. So here we have applied the 10H loss. So after that, the model is training in the two part. The first one is the self-supervised training, which is the combination of this objective function, where we are using only three loss: patch decorrelation loss, alignment loss, and 10H loss. And in second part, after that, we are just adding the classification layer here after this prototype, and we are training the full model with this objective function. And here you can see the result, how our model is generalized. Like when we have trained on patch 4, it is able to detect all the unseen patches from 0 to 9. There is a silent setting and noisy setting. Silent setting is basically when only the patch has been applied to the image and it's unseen during the training. And noisy setting when the patch along with the image corruption has been applied to the image. Here you can see the comparison with the SOTA. So these are the two SOTAs, and this is our performance. We have taken 4 different kinds of backbone, pre-trained backbone for our model, and 2 different kinds of data set in 2 conditions, unseen patches and unseen patches plus noise. Thank you. Thank you, Plaksha University, for giving me this opportunity.
We have time for questions. Yeah, please go ahead.
Okay. Okay.
Why it will have different feature representation for the 2 views of the same image?
So neural network are not robust.
So my question is, given the input image, he mentioned that for the 2 views, it will have different feature representations. So my question is why it will have different feature representations?
As a human, we are robust to the geometric transformation, right? If we are scaling the same image with any dimension, either rotating it, we will still consider that this is belong to this class or this is the different representation of this image. But neural network are not robust to geometric transformation. It has been already shown in the literature. You can find the lots of paper where they can claim that the neural network are not robust to the geometric transformation. So that's why you will get.
Because of the geometric thing, it will have different feature.
Yes.
Okay.
Thanks for the talk. So I wanted to ask about your SSL phase. So in SSL phase, you had.
Can you repeat?
I wanted to ask about your SSL phase.
Assistant phase?
The self-supervised phase.
Self-supervised.
Yes.
Okay.
In your self-supervised phase, you have prototypes, and for assignments, you are using a softmax to assign it.
Okay.
Right?
Yes.
So a lot of people these days are using sync-home normalization to have a good entropy regularized assignments of it. So did you explore it? Did you see like what kind of assignment mechanism works better?
I think I have not explored till yet, but I will look it in the future.
Thank you.
Thank you so much for the suggestion.
So I have a very basic question. Okay, this can be very. One is what you define as out of distribution. For example, in robotics, it's very clear what is out of distribution. For example, if the friction coefficient outside, it's outside the range of my training set.
Yes.
Now it's not yet clear to me what is out of distribution in image in computer vision.
Okay.
Second is that how do you compare your method with a very established technique like contrastive learning, because that also involves learning with negative examples, right, to improve your embeddings and.
Okay.
Yeah.
So for your first question, when we are training with one kinds of adversarial patches, these 9 kinds of adversarial patches is unseen during the training. Means they are out of distribution for this. So this is the answer of your first question.
Right. Yeah.
And
so that this could be a very basic question, right? So, so what is not clear is how would training with these negative examples make my model truly robust?
So you can use different kinds of, it's giving us the security, if this image is manipulated by any adversarial patch, because earlier I have shown that how these kinds of adversarial patches are dangerous for the model and they can reduce the performance of the model, right? So this gives only a security that this image is tempered. You
Security
can't use this
kind of patches.
Okay. Yes, yes.
Yeah. Security against
these kinds of patches.
These kind of patches.
Okay.
So my question is exactly that, I mean, this could be open-ended discussion, what defines an adversarial attack, and so how would this guarantee, robustness? To what extent will it guarantee robustness?
So it's an empirical study. It's not a theoretical study we did. So that,
right.
Okay. I think it's done. Or
I had a second question as well on contrastive learning. Yeah.
So for your second question, I think as per I know, the contrastive laws use the triplet kinds of thing, like there is a positive, negative, and the anchor. Okay, so when we are applying this patch decorrelation laws and we are aligning this feature representation patch wise, we are here calculating the cross correlation matrix and mapping this cross correlation matrix with the identity matrix. So when we are mapping this cross correlation matrix with the identity matrix, it's exactly come closer for the same patch and pull the different patches from there. So
that's my whole point. Contrastive learning does exactly the same.
Yes, yes.
It tries to improve your representation by using negative samples, so that it pulls apart negative samples, so that you get improved robustness and so on.
Yes.
Yeah. So my question is that, have you tried, how does it compare? What do you think about it?
No, I have not tried it. Okay. Thank
you. Any more questions? Okay. I think. Thank you so much. Thank you. Unsupervised domain adaptation for person re-identification via individual preserving and environment switching cyclic generation. Dr. Asa Verma is currently a research fellow at the Singapore Institute of Technology. Her research interests include computer vision with a focus on surveillance on land and sea, as well as natural language processing for human-computer interaction. So today, her specific talk is going to be exploring techniques for adapting computer vision models to new domains while maintaining performance and robustness in real-world scenarios. Over to you.
Hi, everyone. So the title of my presentation today is Unsupervised Domain Adaptation for Person Re-Identification via Individual Preserving and Environmental Switching Cyclic Generation. So first I will talk about what is person re-identification. So person re-identification is the task where there is a query image, and that query image of a person is matched across multiple gallery images taken from non-overlapping camera views. And this task is mainly used in visual surveillance. So I have investigated unsupervised domain adaptation for this task. So first I will talk about introduction. Introduction is first unsupervised domain adaptation. So the motivation is whenever a model is trained on source data set, so whenever it is source data set is labeled, but whenever we try to test it on some another data or some another domain which is not labeled, then, and if we don't train that data, the model with that data, then the model performs poorly. So that is why without fine-tuning, the model always performs poorly. So that is why I want to do a cross-domain translation. So I want to leverage annotated data set from a source domain to benefit an unlabeled target data set, so that it can result in cost reduction and it obviates the requirement of a well-annotated data set. So I will just quickly go through this simplified version of my proposed approach in this paper. So I have labeled data set, unlabeled data set, which is from the target domain. So I extract embeddings from the source domain and the target domain, and then I put both the embeddings to a shared encoder. So the shared encoder, it learns the shared embedding, and these embeddings are sent to the generator to generate some synthetic images. Then what we do is we give some pseudo labels, because I will explain in detail how the pseudo labels are given to these generated images, and then when these images are given the pseudo labels, then the shared encoder is again trained with these images. So this is in a nutshell about the unsupervised domain adaptation. So I will talk about literature survey. So some of the previous works have investigated this unsupervised domain adaptation in various methods for person re-identification tasks. Like IS is the source image and IT is the target image. So in the source image, the shape of the block, it represents the pose, and the color represents the identity, and the outer color represents the background. So some of the previous works, they changed the background and the identity style, but whenever we do a cross-domain translation from one domain to another domain, we want to adapt the style, but we don't want to change the identity of the person, because that will make it noisy, and then we cannot re-identify that person in some another setting. So in some other works, they remove the background completely, so there is a loss of information. So some other work, they change only pose or background, but in our case, we maintain the identity of the person and we change the background and the pose. So now I will talk about methodology. So the proposed methodology is we perform a cyclic generation by first doing cross-domain translation and then the reconstruction of original image. So as you can see, first in the first row, there is labeled source image IS, and then it is domain translated to another domain. Using so the IT, it consists the style and the pose. Style and the pose of the unlabeled target domain image, that is IT, but it consists the identity. Identity features are like the cloth color, or the what the person is wearing. So that is the identity that we consider that as identity in our task. So cross-domain translated images, and then we cyclically reconstruct the original image, because there is a lot of noise when we cross-domain translate the images. So we do a cyclic reconstruction to the original image. So this is one. On the first step, we do a cross-domain translation where we adapt to the style of the unlabeled target domain, and then we do a cyclic reconstruction. So, and then I will talk about here what are the individual and the environmental features. So how are the three encoders in the model differentiated in terms of feature they capture and what loss functions they are trained with. So we have three encoders: pose encoder, EPS is the pose encoder, style encoder is ES, and EID is the identity encoder to capture the identity features. So as you can see, IS is the source image, and then we have 18 channel pose key points. So to get the pose features, we concatenate the source image with the target domain pose to get the pose features. And for style features, we have style encoder. So these encoders are trained with various loss functions to capture the pose features, background features, and the identity features. So what we do, this is a very important step in our proposed method. So we do an environmental swap, that is exchange. So how can we swap the environment features? By concatenating the pose and style features and then feeding them to the decoder. So concatenation of pose and style features. So first we do F is the features, and we concat the F pose and F style features, and then we do a swap. So as you can see in the arrow, in the red arrow, I have shown in the circle the exchange. So exchange, we first concatenate the pose and style features in both the source domain and the target domain, and then we do an exchange of the style environment features. So environment features consist of both pose and style features. So we do a exchange, and then we concatenate with the identity features. So F environment target. So target domain environment feature is concatenated with identity features. So identity feature, for identity feature, there is a shared encoder, which consists shared embeddings, which consists the identity embeddings of both the source domain and the target domain. So then these features are sent to the decoder to get the reconstructed image. So for this, we perform a generative learning. So as you can see, we do a cross-domain translation, then we do a concatenation of features, then we exchange the features. So what we do is, what we do is, since there is a lot of swapping and the concatenation is happening here, so we do a feature consistency loss. So what it maintains, because to learn mapping between two different domains with no information of paired data, we do a feature consistency where we maintain the features. We do a L1 loss between the features, like F individual source features, and the EID, IS2G is the source to domain translated image. So IS2G is a cross-domain translated image. So we do a feature consistency between both the environment features and the identity features. So so the environment features, so the domain translated image will contain the environment feature of the target image and the identity features of the source image. So we will do a L1 loss accordingly for both the features. And it ensures reconstruction of features without noise. So, like I said, so because there is a domain translation is happening, so in addition to feature reconstruction loss, we also do a cyclic reconstruction loss, because from cross-domain translated image, we are then generating a image, again generating the source domain image. So we have IS as the labeled source domain image and IS tilde as the cyclically reconstructed image. So we have, as I have shown in circles in red, it's a cyclic reconstruction loss. So we do a L1 loss between IS and IS tilde in the source domain and IT tilde in the target domain. Then so we have some information. Whenever in the person re-identification task, normally we have two types of information. Suppose there is an identity of the person and there is also another information from which camera the particular image has been taken. So suppose I don't have the information about the identity of the person in the target domain, but I have the information that from which camera the particular person has been captured. So that is why we are using the camera style loss. So LCAM is the camera style loss. So we use a cross entropy loss for that purpose for both the source images and the domain translated images. So since we are using, as you can see, we have a generator block, we use a generative learning, and we have a discriminator. So it is a GAN kind of architecture where the encoder is giving the embeddings, and the embeddings are sent to the generator to generate a domain translated image, and then the domain translated image is sent to the discriminator. So discriminator is trying to learn that more and more, it wants to discriminate more between the real image and the fake image, but the generator wants to generate more and more better images. So we have the adversarial loss. It decreases the gap between real image and the fake translated images. So we have this adversarial loss for to help the generator to generate better images. So we also perform a discriminative learning. So for discriminative learning, we have the identity encoder, which performs discriminative learning, and it is trained with a cross entropy loss. So as you can see, I have shown in circles in yellow that the cross entropy, because we have the source domain label information, so we use that information and we use a cross entropy loss. And then for cross domain translated images, we have the identity features, but the identity features have some noise. So we don't do a hard encoding of cross entropy loss, but we do a soft cross entropy loss where we give some probability, high probability to one of the class, and then give some other small probabilities to other classes. Then we do for discriminative learning, we also do a KL divergence. So KL divergence, it does a supervision of classification on generative images. So we want to bring the probability. Suppose I have my identity encoder is EID, and we also have a standard identity encoder. So what we do is we get the features from that standard identity. So the standard identity encoder is already trained from the images, from source images, and it acts like a teacher, and EID is a student model. So we want to bring the probability distribution of student model close to the teacher model. So our overall objective function is cyclic reconstruction loss, feature consistency loss, camera loss, adversarial loss, cross entropy loss, soft cross entropy loss, and KL divergence loss. And we give hyperparameter with the help of hyperparameter tuning, we specifically design what the weights can be used for these losses. So the training pipeline is we have source image, target image, source image is labeled, target image is unlabeled. We do a generative learning where we have encoder, and then the feature embeddings are sent to the generator where we have the translated images, and then we give pseudo labels to translated images according to the source. Because the identity features are of the source, so we give a pseudo labels, soft cross entropy loss, and then we do cross entropy loss, soft cross entropy loss, and KL divergence loss for a discriminative learning on the identity encoder. So some of the experiments, I will quickly go through these. So the data sets are, we have used two data sets, Market 1501 and Duke MT MCD. Some of the images, they have approximately 30,000 images, and the identities are 1,500 identities for Market, and for Duke 702, and they have been taken from respectively from 6 and 8 cameras. So the results, I have shown ablation study on loss functions because we are using various loss functions. So as you can see, when we translate from Market to Duke, without the cyclic reconstruction loss is very important. So if we don't use a cyclic reconstruction loss, our accuracy is very less. Then we use KL divergence loss, cross entropy, soft cross entropy loss, feature consistency, and camera loss. So here we have shown the source image in the column and the target image in the row, and we see that the source image has adapted to the style of the target domain. So the conclusion is we propose a novel person image generation network for person re-identification tasks. It encodes the pose information to incorporate the global structure of target image, and we do elaborate experiments that demonstrate that our proposed approach generates images with better fidelity and diversity and achieves state-of-the-art re-ID performance. Thank you. Any question?
Any questions?
So what sort of architecture you used for style encoder, pose encoder, and the last identity encoder you had? So
CNN based.
So I could not understand that style encoder you mentioned only background features were coming out. So how?
No, style encoder, because so the background features are, style encoder is taken from the camera images. So we were getting that features with the help of the camera, that from which camera the particular image is taken, and we had the identity of the camera, so it was giving some of the background features.
So it would not be capturing the object features that are present in the image. Only
So
I could not understand how only the background features were coming out from the style encoder.
No, so that is why you know that there are multiple loss functions. So each loss function is trying to optimize the model for a particular features. So initially, obviously, you will not get from the encoder, you will not get the exact features, background features. But the background feature is specifically, background is like, it is a light illumination. How is the illumination of the image? You know, is it a dark image? Is it a light image? So initially, the model will not be able to give you proper features. But if you train the model with the loss function, then it will try to learn that this is light, this is dark, this is sunny, foggy. So these kinds of background features. Okay. So the model will learn those features.
Thank you.
Okay.
What does a camera loss do?
Sorry?
You got a camera loss, right?
Camera loss?
Yeah.
Oh, it's a cross entropy loss.
No, for what? Like, what does it learn?
So it learns like, it learns, suppose a camera is there, and it has been giving the identity that this image, particular image is coming to this identity. So that is how it learns that, okay, these types of images have these features, that they are taken from 6th camera or 5th camera or 1st camera. So a particular type of images from a particular camera will have similar features.
Okay, so if it is from the same camera, then the loss will be less.
Yes, yes. If it is taken from the same camera, the loss will be less. If it is taken from a completely different camera, then the loss will be high.
Okay.
How that information will be provided to training?
You see that from one camera, one type of images are captured. So in a university, there are multiple cameras, like 6 cameras. They are put at. Yes, that information is available. We are using that information, yes.
Thank you for your talk, ma'am. I wanted to ask you, when you separate out the identity and the environment features, how do you ensure that the identity features remain intact, and how do you validate it?
So that is why I explained earlier that we use a feature consistency loss. So feature consistency, so we have first we have source images and then the cross-domain translated images. So we extract the features of the source images and then we extract the features of the from the identity encoder, we again extract the features of the cross-domain translated images, and then we do a L1 loss between them. So this is how the model learn with how much, so it will decrease the loss progressively, and then it will learn the identity features. So we do a cyclic reconstruction and a feature consistency to maintain the identity features. Okay.
So I might ask you the same question I asked the previous speaker, but my first question is that, GANs were popular at some point of time, and then they were replaced by techniques like contrastive learning, because GANs were generally observed to be kind of unstable in the representations they learn. And that's because of the way the optimization happens. There's a minimization and maximization that goes on simultaneously. This can lead to instability in the optimization.
Yes.
I'm curious, why did you pick such a method for optimizing your model compared to a more stable method like contrastive learning? And second is again the same question. How do we know how robust is your model?
So for robustness, when like this, to check the robustness of the model, you will perform a testing on it.
Right.
And I mean, that is very common method that you will perform test on other methods and you will check that what accuracy is coming.
Right.
And then you can get, but that is like the end process. Initially, if we are implementing the algorithm, then how we ensure robustness, then I can say that we can add some noise to the images and then we train with those images as well. So we do an adversarial training before. Right. And instead of, in addition to all these training methods, we do a adversarial training also, so that if any noise is added, an attack is done to an image initially, so then the model can be robust to that kind of.
So one technique, that has been very powerful in robotics is something called domain randomization. It's a very simple technique.
Sorry, what?
Domain randomization, where you just randomize your.
That is a method. That is what I meant.
That could give you more span of.
So that is what I meant by adding noise. That also increases the randomness in the model.
Right.
So instead of overfitting to whatever data overfit, it will generalize to the data.
Right.
Yeah. And one question you asked
on contrastive learning. Why did
I know the contrastive learning is being used, but actually I used GANs because there are GANs, then there are VAs also. Now diffusion models have come.
Correct.
But I used GAN, so I used GAN at the time GANs were famous. So it's not very new paper.
Okay, I see.
It's not a very new paper. Then contrastive learning came and then it became famous. So I have also used contrastive learning in some of my other work to match, I mean,
Yeah.
the probability distributions of the model,
Right,
but not in
right.
this work.
Yeah. Now it's diffusion models.
Yeah, now the diffusion models, yeah.
Diffusion model is a flow matching models.
Flow matching models,
Right.
okay.
And
Okay.
rectified floats.
Okay, I will go through this.
Thanks.
Okay.
Thank you, Asta. Thank you so much.
Thank you so much.
So our next. LumiNet, multispatial attention generative adversarial network for backlit image enhancement. Dr. Mahesh Kumar is an associate professor in the Department of Electrical Engineering at IIT Patna. He serves as an associate editor of IEEE Transactions on Multimedia and is also the editor of IET Journal of Research. Recognized among the top 2% of scientists in AI and image processing by Stanford University, his research focuses on computer vision and image enhancement. Today, his talk will discuss advanced generative and attention-based methods for improving image quality under challenging conditions such as backlighting. Over to you, Dr. Mahesh. Thank you.
Good evening. So today I'm going to discuss the paper which is a little old, 2023. And this is my PhD student's work, Sampreet Bose, and these two authors are internship students. And so I'm going to present the work on backlight image enhancement. Next slide. So backlight image means if a camera is facing the sun, then you will get a distorted image. Objects look more darker because you are compared with the sun. So obviously you look darker. Another problem is next slide. Another problem is low contrast and overexposure. These are the situations occur when you are capturing the image during sunny time, and this is like before street light actually on. It's a traffic signal, traffic video. So that time also reading the number plate is a big issue. Though we have traffic video cameras, you visit any police station, you will find they are facing this problem. So that's why we consider this problem. And we have used here a conditional GAN architecture. And mainly as a generator, we have used UNIT. And for discriminator, we have used one by one patch decoder. And here, we have used a multi-spatial attention blocks. And you can see here, we have given a low resolution image as an input here. And this will generate a fake image. And this is a conditional GAN. That's why we have added this real both places. And we have generated a high resolution image here. Okay. So we have introduced this green color block, actually spatial attention block in the unit. So we are providing the feature map, CNN-based feature maps to this spatial attention module. And spatial attention module has max pool layer and average pool layers, which max pool layers are useful for edges or high-level information, high-frequency information. And average pooling means, average is considered as a smooth area from the image. Okay, and the radio, and then this will be multiplied with again a feature map to generate a spatial attention. So in this way, we wanted to locate the regions where we need a enhancement, contrast enhancement. And this is a one by one patch GAN. And we have used this data set, online available data set, backlight image data set. We have combined actually the three different data sets to get the general approach, to become approach more general. You can see backlight image data set contains images of the real world scenes, libraries, parks, etc. Whereas TM-DIED data set contains images during night time or sunset time, evening time. And single image contrast enhancement contains large images. So image sequence from both indoor and outdoor scenes. Also we have given low light image data set also to the model. So our approaches, this will handle the backlight images also and low light images also. Okay. So that time we didn't collected our data set, so we use all online data set. And you can see the robustness of our input image. We applied Luminate and we got this our enhanced image. So we extracted a number plate, and these OCR models are very common, number plate recognition. There is nothing new. But this pre-processing helped us to extract the number plate. Okay, this is the contribution of this paper. Another is the objective comparison, qualitative comparison I want to show. So we compare with the state-of-art methods. And here this is from traffic video data. So main focus is on traffic signals. Okay. So you can see the signals I have zoomed here. And this is our result actually. This is our result. So in our result, that cycle symbol is visible. In other approaches, cycle symbol not present. Okay. And next is, so these are other enhancement results. So first row indicates the backlight image. Second is the enhanced image, and third is the ground truth. So this is a little bit image processing based contribution. And we compare our approach with various methods. And you can see this, here we plotted a histogram. So blue color indicates the backlight histogram, and red color indicates backlight enhanced image histogram. So what is the difference? Difference is you will find more uniformly distributed histogram. So it is as good as a contrast stretched. Okay, not much clear, but you can see here actually very high numbers. So now they are normalized in the red color curve. Okay. Then same work actually we used for two-wheeler traffic video violation detection. So here we collected data set from mobile camera, then CCTV camera, then external cameras. Okay. So we wanted different scenarios. That's why we collected. And here we have used this gamma correction and Clahe approach. It's a histogram equalization approach. And okay. So that paper's work we use for another paper because it was old paper, 2023. So I would like to present little bit current work also. So in these blocks you can see only the dark region is there, but because of the enhancement we are able to see some information. And then we have collected the data. All these are the images in the IIT Patna campus. This is the entrance of gate number 1 of IIT Patna. And these are actually, we have collected, downloaded. We don't have those images, Philly and Stoppy images. So we classified the data into these 4 classes actually. Triple seat is one of the big issue on Indian roads. So that is one abnormality we consider. Another is a helmet. And third is a Philly and Stoppy, which at India Gate, and you know this type of stunts people do. So we created our own data set and we tested our results. So here also you can see the dark, from dark image to the enhanced image. So if you perform enhancement, then classification will be good actually. Okay, this will help for further processing, any processing, classification, segmentation, whatever. So we have used this. And we published this paper in IEEE Access same year, that time. And this video I will turn. So this is a camera installed at gate number 1 of IIT Patna outside campus, you can see. So it's detecting abnormal blocks actually. So these are our recent papers. We published paper in CVPR, ICPR, and other reputed conferences also. And I'm also working in the healthcare domain, and where we work on MRI-based brain tumor detection, segmentation, classification. Even I work on EEG-based dementia diagnosis, seizure detection. Okay, all those are my areas. Thank you.
Thank you so much, Dr. Kulekar. Any questions? So I have a question. So what are sort of, if your evaluation is towards performance in downstream tasks, like you showed the number plate and the object detection metrics, right? So are there, for example, comparative comparisons with domain adaptation or, similar works which may not necessarily enhance things in the image space, but maybe in the feature space?
Yeah, but that's how we tried actually.
Okay.
Yeah, because it's a old work I just submitted, and we are presenting.
Right.
Yeah, but we have done some other work also, like de-hazing. Our main objective was to address all type of abnormalities. Means first defogging, the de-raining also. If there is a rain, we want to remove the rain and see the face of the person, face of the vehicle. That type of work we have done. But as you have mentioned, we have not explored too much in this area. Okay.
Sure.
Like domain adoption and other things.
All right. Thank you. You have a question?
Okay.
It's going to be of a similar flavor what I asked the other speakers. But this is just out of curiosity,
Right,
I mean, so the question is, what did you observe? In what cases the models failed, and why I'm asking this is that, because no model is completely robust.
Right, that is true.
And what at least it was not clear to me, and even in reading papers, is how robust are these models?
Yeah.
Even to make them robust, what we do is that we collect actual cases that we think could be out of distribution and so on.
Right.
But there is always, right, it's not completely robust, right? And so what I think might be useful is where do these models fail, and upon understanding, maybe,
Right. That's why we tried 2-3 different simple things. So one of them is we use the data set, different data sets, first thing, with the different environment. And secondly, even same question was asked by the reviewer that time in 2023.
Okay.
IEEE transaction on instrumentation measurement.
Right.
But in order to convince him, then we did some small experiment, and we presented on that girl's picture actually. There, that symbol is there, and that's why they convinced actually. Reviewer convinced, and paper accepted that time. That was one contribution. And even this number plate idea was also not there in the previous paper, submitted papers. Because of reviewer, we forced to present some applications or something like, or otherwise theoretically. But instead of that, we use this approach.
Right.
To prove with some applicable things actually. Yeah.
Okay. Thank you so much, Dr. Kulekar. I'll request Dr. Renu to please come on the stage and present mementos to all the speakers. I'll request all other speakers to also please come on the stage. We'll just take a group photograph first, and then we can present the mementos. Also, please stay back. There are a few announcements after the photograph. Please.
My student is going to be actually, so he didn't come. Same student.
Thank you. I'll request Dr. Renu to please present the memento. Dr. Asta. Mr. Rishabh. Mr. Vishesh. Dr. Kolikar. Thank you, Dr. Renu. I'd like to call Professor Rajesh to please conclude the session.
So we have two important announcements. One is there is a poster session after this, which will happen in HDFC building. We'll take you there. You might have seen that building already. And the second thing is a bit more formal thing to say, but also from the heart, that I have to say thanks on behalf of OC members, especially the session chairs, the speakers, and the attendees. I'm sure you enjoyed your day, which was full of, topics starting from language models to healthcare and whatnot. And I'm sure you must have, a lot of discussions and created new connections, not only in this room, but also in the corridor or hallways. And these connections will help you, making new collaborations, even once you leave here. And the thing is, I'm sure you're very tired, but next day, it's full of great eminent speakers who are coming from all different parts of the world to give, very exciting talks. So we'll look you tomorrow. And but before we leave, please, we'll have to move to the poster session in the HDFC, and then there is a dinner. Yeah? Okay. Thank you very much.
You want to say? किसका काम? उसको बोलना था सब HDFC